Welcome to Night Science Tales tonight. We begin a gentle journey into the hushed world of mushrooms, those quiet decomposers of the forest floor. We are not here for heavy instruction or rigid facts, but for gentle, sleepy stories of how these wonders grow and drift through the soil. We will uncover little secrets about their hidden networks, the soft threads beneath the earth, and the quiet ways they glow and whisper in the dark woods. Allow your mind to relax, settle your breathing, and let us drift slowly with the wonders of mycology, exploring the calm shapes and surprising lives of these humble fungi. If these gentle stories help ease you towards sleep, please consider liking this video and subscribing to Night Science Tales so you can enjoy more calm journeys with us in the future. Point 1. The vast majority of a fungus exists as unseen mycelial threads, silently weaving through the damp earth like a pale, delicate hidden net. This intricate network is a quiet masterpiece of biological engineering, unfolding slowly beneath the layer of leaf litter and cool, dark soil. Each thread, known as a hypha, extends with patient precision, navigating around tiny grains of sand and capturing minuscule pockets of moisture. It is a slow, methodical expansion, often covering acres over the course of years, long before any fruiting body dares to breach the surface and announce its presence to the sun. The collective mass of this subterranean structure far outweighs the brief, visible mushroom cap, acting as the enduring consciousness of the organism, the deep, resting root of its being. These threads operate in constant communication, transmitting chemical signals across the soil matrix, sharing resources like a vast, decentralized silent mind. They break down the complex polymers of fallen wood and decaying leaves, quietly participating in the endless cycle of respiration that releases carbon dioxide back into the steady, upward drift of the atmosphere. Gravity holds the moist earth close, pressing the hyphal filaments into intimate contact with the mineral structures and the sleeping roots of nearby plants, forming crucial symbiotic partnerships that nourish the entire ecosystem. We seldom consider the immense labor happening just centimeters below our feet, the pale, quiet architecture of life seeking water and stability in the constant, cool darkness. This expansive web reminds us of the quiet, unseen forces that govern life, a slow, continuous weaving that requires no light, only patience, and the persistent presence of dampness in the unchanging earth. The fine filaments are so delicate they feel like spun sugar, yet they possess the quiet strength needed to exert subtle pressure and reshape the very composition of the sleeping soil they inhabit. Point 2. Spores are released into the still night air, drifting on the slightest breeze, sometimes numbering in the trillions from a single cap. This quiet, biological event is governed by the soft physics of aerodynamics and the molecular push of humidity. When the cap is fully mature, the reproductive cells, tiny and light beyond comprehension, are gently ejected into the atmosphere. They rely on the subtle convection currents created by the gradual cooling of the earth after sundown, or the infinitesimal displacement caused by a dewdrop forming on a nearby leaf. These multitudes of spores are then lofted upwards, escaping the immediate pull of local gravity, entering the vast, slow river of the air. Each spore is an encapsulated promise, a minute piece of genetic material suspended in the silent void, waiting for the gentle hand of chance to guide its descent. Even when the air seems entirely motionless, there are slow, vast movements high above the canopy, quiet atmospheric tides that carry these minuscule particles over forests, mountains, and sleeping valleys. The sheer number of trillions ensures that probability favors eventual settlement, distributing the organism across time and space. Think of the spores not as individual units, but as a fine biological dust, catching the muted, distant light of the moon as they float silently downwards through the upper layers of the dark air. They may travel for days, riding the gentle, steady flow of air molecules, until they are finally brought to rest by the soft friction of a damp surface or the quiet gravitational pull towards a bed of suitable, decaying organic matter. This silent dispersal is an ancient, tireless process, a continuous rain of life descending upon the sleeping earth, ensuring the continuity of the organism through the patient repetition of biological cycles. Point 3. Puffballs release their powdery contents with a gentle sigh when disturbed by the soft touch of falling rain or a small creature passing by. The mature puffball is a reservoir of dried spores, held within a papery, brittle skin that rests lightly on the forest floor. The exterior shell, having completed its protective duty, is now exquisitely sensitive to the subtle pressure changes around it. When a single large raindrop, heavier than the structure itself, lands with a soft PFF upon the surface, it creates an instantaneous compression. This gentle external force compresses the air within the sac, causing the powdery mass of spores to be expelled through a tiny apical pore. Like a quiet, smokeless puff of biological steam, it is not an explosion, but a quiet exhalation, a slow burst of life into the humid air. Similarly, the soft, padded step of a vole or the deliberate crawl of a beetle across the forest moss can provide just enough momentary pressure to trigger this release. The resulting cloud, a soft plume of golden brown or dark olive dust, hangs momentarily in the still, dim air, refracting the weak light that filters down from the canopy. It is a passive defense and a quiet mechanism of propagation, relying entirely on the slow, steady activity of the external world. The sound is almost imperceptible, a hushed whisper carried away by the damp fibers of the air, a miniature, earthbound cloud that drifts close to the ground before the spores are distributed over the nearby moss and soil. This delicate response illustrates the exquisite calibration of nature, where the softest interaction, the weight of water, the passing of a small life, is enough to initiate the critical phase of reproduction, a slow, patient reliance on the environment's steady rhythm. Point 4. The soft cap of a chanterelle often curls slightly at the edges, catching the dim forest light in a quiet, golden, funnel-shaped embrace. This gentle curvature is a characteristic of its slow, persistent growth, responding subtly to the pull of gravity and the direction of minimal sunlight filtering through the dense overhead foliage. The chanterelle prefers the quiet, shaded sanctuaries beneath the old-growth trees, where the light is diffuse and cool. As the mushroom matures, the cap expands horizontally, and the margins begin their delicate upward turn, creating a soft, uneven bowl. This shape, resembling a gentle, inverted bell or a natural funnel, serves to subtly guide raindrops and condensation toward the center stem, ensuring that the moisture is channeled down to the roots and the unseen mycelial network below. The golden color is soft and persistent, reflecting the muted green and brown palette of the forest floor, acting like a tiny, luminous beacon in the deep shade. It is not a harsh, reflective shine, but a velvety, deep hue, enriched by the moisture it has absorbed from the cool, damp air. If you trace the edge with an imaginary finger, you feel the slow, steady geometry of its development, a continuous curve perfected by the patient passage of days. This silent architectural detail is part of its slow identity, contrasting with the often flat or highly structured caps of other fungal species. The chanterelle seems to offer a quiet welcome, its curling edges reaching upward just slightly, as if attempting to hold a small portion of the fleeting, fragmented light of the forest, settling into its golden, quiet posture as the shadows lengthen and deepen around its base. Point 5. Many fungi rely on the deep, flowing currents of underground water to distribute nutrients and signals across great distances beneath the soil. The water beneath the earth is not static. It moves with an almost glacial slowness, obeying the patient gradient of gravity and the permeability of the rock and sand structures it encounters. This subterranean flow acts as an invisible circulatory system for the vast fungal networks. Dissolved organic molecules, trace elements, and signaling compounds are picked up by the water as it seeps through the porous soil, gently transporting these vital components far beyond the reach of the original fungal threads. The mycelium secretes enzymes that slowly break down complex matter, and the resulting soluble nutrients are then carried away by the passing water molecules, moving silently through the dark channels and minute soil pores. This method allows fungal colonies that are widely separated spatially to participate in a shared, slow economy of resources. It is a system built on patience and the inevitability of the water cycle. Rainwater, absorbed slowly by the earth, becomes the medium for this steady, deep communication. The movement is so gradual that it resists disruption, ensuring a constant, stable flow of information and sustenance over weeks and months. Consider the path of a single molecule of sugar, dissolved in the cool groundwater. It is picked up near an oak root, carried steadily past grains of quartz, and finally deposited hundreds of feet away, where another section of the mycelium waits to quietly absorb it. This reliance on the deep, hidden currents highlights the quiet interconnectedness of the subterranean world, where water acts as the silent, tireless courier of life and information through the unchanging dark point 6. Beneath the cap, delicate gills hang in perfect, parallel arrangements, acting as silent, miniature architects housing reproductive cells. These structures, known technically as lamellae, are formed with an astonishing precision, aligning themselves radially outward from the stem, creating numerous thin, vertical surfaces. The regularity is quiet and mesmerizing, a biological geometry developed through countless generations to maximize surface area within a limited volume. Each gill is an engine of cellular reproduction, dedicated to the patient, unseen task of spore production. Within the soft, damp tissue of the gills, specialized cells quietly undergo mitosis, the slow, steady division that results in the formation of basidiospores. These spores are attached to minute stalks, patiently waiting for the precise moment of their ballistic release. The parallel alignment is crucial for spore dispersal, creating narrow, windless channels where gravity can gently and consistently draw the falling spores downwards, preventing them from catching on the adjacent surfaces. If the gills were not perfectly vertical and parallel, the spores would stick, blocking the continuous reproductive flow. The air trapped between the gills remains still, a quiet, humid environment that facilitates the precise trajectory of the spores as they descend towards the open air below. This architecture is a silent testament to efficiency, a quiet, functional beauty where every angle and curve is optimized for the slow, continuous mission of propagation. The gills hang in the cool, dark space beneath the sheltering cap, performing their continuous molecular labor, waiting for the gentle flow of air to carry their microscopic products away into the vast, open world. Point 7. Bracket fungi adhere closely to old, sleeping trees, creating quiet, overlapping shelves that feel like soft, woody semicircles against the bark. These organisms, often called conchs or polypores, embody stillness and permanence, growing slowly, year after year, adding new layers of dense, quiet tissue to their edges. They form a slow, structural embrace with the host tree, often settling into the deep crevices and grooves of ancient, weathered bark. Unlike the fleeting, soft mushrooms of the forest floor, bracket fungi are enduring, sometimes remaining fixed to the trunk for decades, patiently carrying out their role as decomposers of lignin and cellulose. Their structure is designed for resistance, facing the slow wear of rain, wind, and the quiet pressure of frost. The shelves appear to be resting places, quiet platforms built upon the vertical plane of the trunk, providing shelter for small insects and catching the steady fall of dust and debris. Each concentric ring etched upon their upper surface marks a year of slow, deliberate growth, a silent biological record of the passing seasons. They often overlap gently, creating tiered arrangements that follow the subtle contours of the sleeping tree, adapting their quiet, woody geometry to the imperfections of the host. They are the patient architects of decay, quietly converting the hard, complex structures of the dying wood back into the simple components needed by the soil. Their presence is a sign of the steady, inevitable cycle of life and death in the forest, a visible manifestation of the Earth's quiet digestive process. They sit in solemn stillness, affixed with silent determination, absorbing the soft sounds of the forest and patiently awaiting the slow, steady completion of their work upon the ancient, standing trunk. Point 8. Some species glow faintly in the dark through bioluminescence, casting a calming, pale green hue upon the deep forest floor at midnight. This quiet light is known as cold light, produced not by heat, but by a precise chemical reaction involving enzymes like luciferase acting upon oxygen and specific organic molecules. It is a silent, gentle illumination, utterly lacking the aggressive brilliance of sunlight or the sharp glare of human lighting. Instead, the pale green sheen is diffused and soft, just bright enough to trace the damp contours of moss or the structure of a decaying log where the fungus has taken hold. This phenomenon occurs in the deepest part of the night, when the forest is steeped in absolute shadow, and the moon is often obscured by clouds or dense canopy. The glow is slow and persistent, a steady, low-energy emission that requires no external stimulus. It is thought by some scientists to be a way to attract nocturnal insects, which then inadvertently carry spores to new locations. A quiet, gentle lure in the vast darkness. The light seems to pulse with the quiet rhythm of the forest's hidden life, a ghostly, soft radiance that underscores the deep, comforting stillness of the midnight hour. Looking upon this pale green emanation instills a profound sense of quiet mystery, a reminder that energy conversion is constantly occurring, even in the most shadowed and remote corners of the world. It is a natural nightlight, steady and unwavering, a silent beacon that speaks only of chemical patience and the slow, consistent movement of biological energy through the sleeping ecosystem. Point 9. The smell of many mushrooms is a subtle, earthy perfume, evoking the comforting scent of rain-soaked woods and cool, dark moss. This aroma is composed of complex volatile organic compounds, molecules released into the still air from the damp living tissue. Often, the most dominant note is geosmin, the organic compound responsible for the deep, fundamental scent of freshly turned soil, and the atmosphere immediately following a gentle summer rain. This quiet perfume carries a comforting historical weight, genetically linked to the processes of decay and renewal that sustain life on Earth. When you breathe in this scent, you are inhaling the molecular narrative of the cool, hidden life cycle of the forest floor, a blend of moisture, minerals, and the slow transformation of organic matter. The smell is strongest after a period of prolonged dampness, when the air is heavy and cool, allowing the molecules to linger close to the ground, concentrating the olfactory experience. It is a deep, grounding aroma that lacks sharpness or acidity, remaining smooth and steady. It speaks of deep shade, of centuries of accumulated leaf litter, and of the constant presence of water percolating through the dark earth. This subtle perfume acts as a quiet map for many forest creatures, signaling the presence of rich nutrients and moisture. For humans, it is a primal scent, inducing a sense of deep quiet and belonging to the natural cycles, a gentle olfactory lullaby of earth and moss, and the steady flow of forest time. 10. Matsutake mushrooms are prized for their shy nature, often hiding almost completely beneath a thin blanket of fallen pine needles and leaf litter. Their reluctance to appear fully above ground is a quiet survival mechanism, affording them protection from drying sun, sudden winds, and the attention of foraging animals. They favor a deep, undisturbed relationship with specific pine tree roots, forming a crucial mycorrhizal bond that requires stability and patience. The fungal body often pushes up gently beneath the layer of duff, creating only a slight, almost imperceptible mound or crack in the compacted surface of the pine needles. To find them requires a slow, deliberate searching technique, demanding quiet observation rather than aggressive digging. One must look for the subtle displacement, the barely visible lift in the smooth carpet of needles, or the pale, dusty outline of soil where the mushroom has caused a minor upheaval. This stealthy growth means they are discovered not through sight, but through a slow, systematic attention to the quiet textures of the forest floor. They remain buried, sheltered by the insulating layer of dry, accumulated organic material, maintaining a stable temperature and humidity crucial for their slow development. The act of finding a matsutake is therefore a quiet dialogue with the forest, a patient negotiation requiring the forager to slow down their steps and attune their senses to the subtle, almost silent signs of life beneath the surface. It is a lesson in quiet concealment, where the greatest treasures often prefer to remain modestly tucked away, requiring a gentle touch and a profound respect for the layers that protect the deep, sleeping heart of the earth. 11. Fairy rings trace a silent geometry upon the forest floor, a soft, slow measurement of time that is imperceptible to the hurried eye. These circles are not sudden occurrences, but rather the quiet, fruiting manifestation of an ancient, hidden network lying deep within the soil. Beneath the damp moss and the settled leaves, the mycelial colony stretches its fine, white threads outwards, molecule by molecule, year after steady year. It begins from a single, settled spore, perhaps carried on the gentle draft of the forest air or deposited by the soft passage of a foraging insect. From that point of origin, the web of life unfurls, expanding radially, seeking out nourishment and quiet stability in every direction simultaneously. As the colony grows, the central area slowly exhausts the available resources, prompting the living edge to reach further into the richer, untouched soil. This outward march creates the perfect, expanding ring visible above the surface. The fruiting bodies, the mushrooms themselves, emerge only briefly to disperse their spores into the slow-moving atmosphere, marking the perimeter like quiet sentinels. The diameter of the ring gently increases by mere inches, or sometimes just fractions of an inch each season, a geological clock ticking slowly through the decades. To stand within one is to stand in the history of quiet biological labor, feeling the slow pulse of the Earth's continuous, gentle respiration, observing a circumference that reminds us that growth is often a matter of infinite, patient repetition. The ring continues its expansion, a testament to the constancy of life beneath the surface, a soft, steady rhythm of organic expansion that holds the silence of the earth in its circular embrace. 12. The deep quiet of the forest floor is not merely an absence of sound, but an actively manufactured stillness, woven by the very textures of the organic world. Certain fungal stems possess a soft, downy texture, a gentle velvet nap that plays a subtle but profound role in the acoustic ecology of their humid domain. Sound waves, which are merely vibrations traveling through the air molecules, meet this soft surface and are immediately fractured and diffused. Instead of bouncing back as an echo or a sharp reflection, the energy of the vibration is absorbed and gently converted into minute amounts of heat within the fungal cells, vanishing into the structure itself. This soft absorption prevents the buildup of noise, damping the slight rustle of insect wings or the soft settling of a dust particle. The structure of the velvet is built of myriad microscopic fibers, creating complex pockets of air that trap and dissipate the energy of passing sound, similar to how deep moss cushions the forest floor. When a gentle breeze sweeps through the undergrowth, the resulting whispers are muted, softened, and held close to the ground, never allowed to swell into a sharp disturbance. This biological muffling effect contributes to the deep, consistent hush that characterizes the habitat, protecting the delicate biological processes of the fungi and the surrounding flora. It is a quiet architecture, where the very surface materials are designed for stillness, reminding us that silence is a palpable quality, carefully curated by the textures of the living, damp earth, ensuring that the necessary peace for slow growth is maintained hour after steady hour. 13. The wood ear fungi offer a unique experience of organic texture, possessing a thin, almost translucent quality that feels gently gelatinous and remarkably pliable beneath the lightest touch. This feeling of soft, cool elasticity is due to specialized cellular matrices designed specifically for the capture and patient retention of water molecules. When fully hydrated after a soft, steady rain, the fungi swell subtly, becoming fuller and exhibiting a deep, quiet resilience, resembling soft, folded petals or perhaps the lobe of an ear, gently curved toward the damp earth. Yet the true marvel of the wood ear lies in its capacity for profound patience during periods of dryness. When the air becomes crisp and the humidity recedes, the water slowly evaporates from the tissues, causing the structures to shrink and desiccate, becoming tough, brittle, and seemingly inert. In this state of suspended animation, they await the return of the life-giving moisture. They are not destroyed by the dryness but simply paused, holding their breath in the quiet cycle of the forest. When the first dew descends or a gentle shower begins to fall, the dry tissue absorbs the water rapidly through osmosis, regaining its soft volume and pliant texture within hours. This steady, rhythmic cycle of desiccation and rehydration is a testament to the fungi's slow mastery of biological timing, teaching a quiet lesson about the inevitability of change and the wisdom of stillness. They simply hold their form, waiting for the cosmic balance of the hydrological cycle to return their soft, gelatinous fullness, a silent promise kept between the fungi and the passing clouds. 14. Deep beneath the layered composure of the forest floor, where the sunlight never intrudes and the temperature remains in a constant, soothing equilibrium, the truffle undertakes its quiet, subterranean alchemy. It is born and matures in the profound, uninterrupted stillness of the deep ground, sheltered from the sudden shifts of weather and the noisy passage of the surface world. This constancy is essential for the slow, meticulous synthesis of its complex aromatic compounds. Without the variable energy of sunlight to drive sudden metabolic spikes, the truffle's growth is slow, steady, and focused entirely on the chemical production that defines its essence. The aromas, which are primarily volatile organic compounds, develop slowly, accumulating intricate layers of earthy, nutty, and musk-like notes, derived directly from the minerals and decaying matter surrounding them. The pressure of the soil above contributes to the density of the fruiting body, ensuring that this fragrant essence is tightly locked within its quiet structure. The absence of air movement beneath the surface means the aromatic molecules are not dispersed, but held in close proximity to the mycelial network, intensifying their complexity over weeks and months of undisturbed growth. This dark, constant environment fosters a type of patient perfection, where time is measured not by day and night, but by the slow, inexorable migration of nutrients through the root systems of the host trees, with which the truffle quietly collaborates. It is a slow, silent fermentation in the dark laboratory of the earth, proving that the deepest quiet often yields the most profound and concentrated results. 15. The quiet work of the decomposer fungi is among the most essential and unsung tasks in the perpetual cycle of the forest, a patient process of structural reversal. When a great tree finally succumbs to gravity and returns to the earth, its sturdy, complex cellulose and lignin structures become the raw material for this silent transformation. Specialized fungi approach the fallen wood, not with force, but with molecular precision, secreting gentle yet potent enzymes that slowly begin to dissolve the rigid bonds of the wood fibers. This dissolution is a microscopic, continuous endeavor, a slow-motion dismantling of complex chemistry. Over months and years, the fungi patiently break down the dense, structural components, releasing carbon and essential nutrients back into the soil matrix. The hard wood softens gradually, losing its stiffness and rigidity, passing through stages of spongy decay until it finally achieves the consistency of smooth, reusable dust. This dust is indistinguishable from the earth itself, perfectly integrated and ready to nourish the next generation of silent, waiting seedlings. It is the ultimate act of recycling, performed without fanfare or speed, simply an inevitability of natural physics and biology working in seamless harmony. The fallen log becomes a temporary slow-motion mountain, and the fungi are the quiet rivers that gently erode it back into the valley floor. This process maintains the steady nutrient flow of the ecosystem, ensuring that nothing is truly lost, but only transformed and repurposed in the deep, constant rhythm of planetary respiration. They are the quiet custodians of balance, turning history back into potential, one dissolved molecule at a time. 16. The visual stillness of the lion's mane mushroom presents a mesmerizing paradox, resembling the sudden freezing of fluid motion, like a gentle waterfall suspended in the quiet air of its humid habitat. Instead of possessing a defined cap and stem, this structure is composed entirely of soft, delicate white tendrils that cascade downwards in remarkable uniformity. These spines, technically known as teeth, exhibit a subtle form of negative geotropism, meaning they grow away from the pull of gravity and toward the open, humid space below. Yet their resulting shape is entirely governed by that very downward force. Each tendril hangs perfectly vertical, maintaining its alignment because the air remains still, and the growth rate is exquisitely slow and steady. The density of the moisture in the surrounding air is critical, preventing the fragile, filamentous extensions from drying out or collapsing prematurely. They hang like silent curtains in the shadowed recesses of the wood, catching the soft, diffused light and appearing almost luminescent against the darker bark. The slow, gradual elongation of each spine is a testament to unhurried, continuous growth, a biological slow dance with gravity and ambient humidity. There is no haste in its formation, only the quiet, persistent effort of cellular replication, extending the soft boundaries of its form into the space around it. To look upon the lion's mane is to witness a moment of perpetual stillness, where the dynamic chaos of water falling has been translated into the quiet permanence of fungal tissue, providing a soft, comforting focal point in the deep, undisturbed peace of the forest interior. 17. When the slow, dependable cycle of the seasons brings forth a period of dryness, and the forest floor begins to crisp under the low humidity, the fungi demonstrate an unparalleled capacity for patient stillness. They do not vanish entirely, but rather retreat quietly into their expansive, hidden infrastructure, the mycelium, which is deeply interlaced within the soil and decaying matter. This root-like network acts as a quiet reservoir and a secure retreat, concentrating the minimal available moisture deep within its fine, protected filaments. The fruiting bodies, which are exposed and vulnerable to desiccation, may wither and dissolve, returning their moisture content to the parched atmosphere, but the core life force remains safely underground, entering a state of biological stasis. Metabolism slows significantly, the quiet processes of energy consumption dropping to the bare minimum required for basic survival. It is a profound act of waiting, an implicit trust in the inevitability of the hydrological cycle. The fungi hold their breath, conserving every precious molecule of water, knowing that the Earth's orbit and the gentle currents of the atmosphere will eventually deliver the refreshing dampness once more. Days turn into weeks in this quiet dormancy, until the subtle vibration of atmospheric change signals the return of the soft, continuous rain. Upon contact with the reviving water, the cells begin to swell, metabolism accelerates, and the quiet internal pressures rise, signaling the network that it is safe to slowly, patiently, bring forth new life into the now moistened world above. 18. The geometry and chemistry of many mushroom caps are designed for a quiet interaction with moisture, a phenomenon visible in the gentle movement of dew and rain upon their surface. Often, the cap is coated in a faint, waxy, almost invisible film, a natural lipid layer that provides effective hydrophobicity. This means the surface gently repels water molecules, preventing them from spreading or soaking into the delicate tissues beneath. Instead, the water coalesces, drawn into the smallest possible spherical shapes by the physics of surface tension. These miniature globes of moisture, the dew drops, rest lightly upon the waxy surface, reflecting the dim, filtered light like tiny, perfect lenses. As gravity slowly exerts its influence, or as the cap subtly adjusts due to temperature change, these beaded drops begin their silent journey. They do not rush, but travel with profound slowness, gliding almost frictionlessly down the gentle curve of the cap toward the edge. The waxy film acts as a smooth, natural lubricant, ensuring the drops roll off silently and cleanly, depositing the collected water directly onto the base of the stem or the waiting, damp earth below. This efficient shedding of water prevents the surface from becoming overly saturated or compromised by standing moisture, maintaining the structural integrity of the cap. It is a slow, methodical process of passive cleansing and hydration channeling, a perfect, quiet interaction between the living organic surface and the soft physics of water tension, perpetually preparing the mushroom for the steady hours ahead. 19. There is a precise, quiet choreography governing the expansion of the quietest mushrooms, often timed impeccably to coincide with the softest transition of the day, the hush of dawn. Just as the residual darkness begins to yield to the first, filtered hues of pale gray and silver, these fungal structures begin their slow, deliberate unfurling. This opening is not a rapid, energetic motion, but a gentle expansion driven by minute changes in cellular turgor pressure. Water is slowly pumped into the cells along the edges of the developing cap, causing the structure to swell and flatten outward, transforming from a tight bud into a broad, receptive surface. The timing is crucial, driven by subtle circadian rhythms synchronized with the planet's rotation. By opening at this transitional moment, they maximize their exposure to the minimal light that manages to filter through the dense, heavy structure of the forest canopy above. While fungi do not photosynthesize like plants, many species use these low-light conditions as a subtle cue, a gentle signal to complete their final developmental stages before the humidity begins to drop later in the morning. The expansion is so slow, so steady, that it is impossible to perceive without patient observation or time-lapse recording. It is a testament to biological patience, a graceful, unhurried bow to the rising sun, ensuring the spore-bearing surfaces are perfectly positioned in the cool, stable air of early morning, fulfilling their final purpose in quiet, steady obedience to the ancient rhythms of light and shadow. 20. The choice of habitat for many fungal species is a profound appreciation for environmental constancy, seeking out the shadowy recesses and deep corners of the forest floor where external variables are naturally muted. The dense, layered architecture of the canopy acts as a massive, organic filter, scattering and absorbing the intense energy of direct sunlight. What reaches the forest floor is not harsh illumination, but a soft, diffused green light, gentle enough to cue biological processes without introducing disruptive heat. This filtered light is the key to maintaining a cool, consistent microclimate, essential for the delicate, water-filled structure of the fungi. High temperatures cause rapid evaporation, threatening the structural integrity and metabolic function of the fruiting body. By remaining in the perpetual shadow, the ambient temperature remains low and predictable, preventing the sudden, sharp fluctuations that characterize open environments. Furthermore, this stillness preserves the crucial humidity near the ground, minimizing water stress and enabling the fragile caps and gills to remain pliant and fully hydrated. The soil temperature beneath the canopy shifts slowly, buffering the fungi against the rapid heating and cooling cycles of the surface world. It is a gentle reliance on the massive thermal inertia of the Earth itself, utilizing the depth and the shadow as silent stabilizers. The fungi thrive in this quiet predictability, demonstrating that stability, stillness, and softness of light are often the most crucial ingredients for the continuation of their subtle, beautiful life cycle, far away from the energetic intensity of the sunlit world. 21. Some boletes have a smooth, spongy underside instead of gills, allowing the spores to quietly drop through tiny, soft pores onto the ground. The bolete stands firm upon the forest floor, a silent structure built not for sudden fanfare, but for slow, deliberate dispersal. Unlike the delicate, radiating architecture of gills, which requires precise orientation to the vertical plane, the spongy cushion beneath the bolete cap presents a geometry of soft redundancy. This cushion is an intricate honeycomb of small, tubular channels, each ending in a circular pore that opens gently toward the damp soil below. These pores are perfectly calibrated openings, gateways through which the microscopic reproductive units must pass. Within the tubes, the spores mature in a sheltered darkness, waiting for the precise moment when they are ready to answer the call of gravity. There is no violent action here, no forceful expulsion needed to clear the crowded field. Instead, the process relies on the quiet inevitability of downward pull. Each spore detaches softly from its generating cell and begins a simple, short journey, descending through the smooth, open passage. The air within the tube is still and humid, helping to guide the infinitesimal particles without agitation. They drift, weightless in their short fall, eventually emerging from the pore's lip, settling like a faint, imperceptible dust cloud onto the earth, ready to begin the slow cycle of germination beneath the leaf litter. An entire reproductive strategy centered on stillness and the subtle influence of planetary mass. The entire cap acts as a broad, velvet-textured sieve, designed for maximum collection and minimum energy expenditure, a testament to efficiency in the deep, quiet corners of the ecosystem, patiently awaiting the gentle disturbance of wind or rain to further scatter its quiescent progeny across the silent landscape of the woodland floor. 22. The mycelium can communicate with plant roots using gentle chemical signals, establishing a silent, mutual relationship beneficial to the entire forest. Deep beneath the surface, where sunlight never penetrates and sound is muffled by centuries of accumulated earth, an expansive conversation is constantly taking place. This conversation is not spoken but chemically composed, transmitted through the vast, invisible network of fine fungal threads known as the mycelium. These delicate white strands, the foundational infrastructure of the fungal organism, gently encounter the root tips of towering trees and small woodland herbs. When contact is made, a silent biological handshake occurs, mediated by complex signaling molecules. The mycelium offers the plant highly efficient access to essential nutrients like phosphorus and nitrogen, which it has painstakingly extracted from distant, tightly bound soil compounds. In return, the plant, having utilized the energy of the sun through photosynthesis, gently releases small quantities of synthesized carbon compounds, sugars, back into the fungal network. This exchange is the basis of a profound mutualism, a silent promise kept between kingdoms. The chemical whispers travel slowly across the vast network, a flow of molecular information that regulates the distribution of resources across the entire forest biome. If one tree is stressed, the network may subtly redirect sustenance from a neighboring, healthier host, ensuring the collective survival of the community. This subterranean system acts as a slow, decentralized intelligence, managing the collective life of the forest through infinitesimal chemical gradients and steady, measured exchange rates. A quiet biological internet weaving life into the very structure of the earth, proving that the deepest connections are often the most silent and enduring, constantly maintaining the delicate equilibrium of the living world. With profound patience. 23. Indigo milk caps release a slow, bluish-purple liquid when broken, a striking but non-alarming color shift occurring in the deep shade. The indigo milk cap rests quietly amongst the damp moss, its subdued coloring often allowing it to merge seamlessly into the shadows and the natural patina of decomposition. But when its structure is gently breached, perhaps by the soft pressure of a footfall or the quiet nibbling of a small insect, a fascinating, slow chemical event unfolds. Specialized internal cells, called lactifers, which contain a milky fluid known as latex, are ruptured. This latex slowly begins to weep from the wound, a thick, viscous flow that momentarily holds a startling, unearthly hue. The original liquid may start as a pale, almost invisible serum, but upon exposure to the oxygen molecules in the ambient air, a precise enzymatic reaction begins. This process catalyzes the transformation of precursor compounds within the latex, resulting in the formation of a stable, deeply saturated bluish-purple pigment. The color shift is gradual, not instantaneous, giving the impression of a slow internal blush spreading across the wounded surface. This natural staining, a chemical self-disclosure, is striking, but holds no harshness in the muted light of the forest floor. The blue tones are deeply soothing, reminiscent of twilight skies or the deep, cold colors of glacial ice, entirely fitting for a creature that thrives away from the vivid greens and yellows of direct sunlight. This quiet effusion of color is a steady, predictable phenomenon, a reminder that even the most grounded life forms hold within them the capacity for deep, subtle, and profoundly beautiful molecular transformation, occurring entirely without noise or rush in the silent theater of the woods. 24. Lichens, which are cooperative forms of fungi and algae, cling peacefully to rocks and trees, slowly aging with their silent host structures. Lichens embody the concept of slow time, existing in a state of profound patience against the backdrop of geological processes. They are not a single organism, but a stable, unified partnership, a carefully constructed alliance where fungal hyphae weave a protective matrix around photosynthetic algae or cyanobacteria. This partnership allows them to survive on surfaces where almost nothing else can take hold: bare rock faces, weathered wood, or exposed granite. The fungal partner provides structure, moisture absorption, and shelter from environmental extremes, while the algal partner quietly generates the energy needed for sustenance using the light of the sun, a delicate balance sustained across centuries. Their pace of life is glacial. Some species expand only a few millimeters over the course of an entire decade. They cling to the silent permanence of their hosts, etching themselves into the landscape. On massive stone structures, lichens act as biological clock faces, their measured expansion rates sometimes used by scientists to date ancient rock movements or exposed surfaces. They absorb the soft history of the air and the minerals of the rock, slowly contributing to the quiet process of biological weathering, releasing faint organic acids that subtly erode the stone beneath them. They exist in a state of tranquil adhesion, witnessing countless cycles of sun and snow, undisturbed by the fleeting changes that sweep through the world below them. Their steady, silent presence speaks of the deep, slow persistence of life, a constant, low-frequency hum of existence against the vast, indifferent silence of geological millennia. 25. The fairy lantern mushroom has a slender, almost transparent stem, allowing the soft interior light of the forest floor to pass gently through its structure. The fairy lantern mushroom is an ephemeral study in translucence, a delicate form whose very structure seems designed to interact poetically with the filtered light of the deep woods. Its stem, or stipe, possesses cellular walls of exceptional thinness and purity, allowing ambient photons to pass through its tissues with minimal obstruction. The light that reaches the forest floor is already soft and diffused, having traveled through layers of canopy leaves, breaking into dappled patterns of green and shadow. When this gentle light encounters the mushroom stem, it does not stop, but is merely refracted, bending slightly as it passes through the column. This internal illumination creates a subtle glow, a quiet radiance that seems to come from within the very substance of the mushroom itself. The organism appears almost immaterial, an outline defined more by the light it lets pass than the shadow it casts. This transparency serves a biological purpose, reducing the need for opaque structural material, allowing the mushroom to rise swiftly and lightly towards the soft, muted air. It stands as a fragile spire, absorbing the diffused luminance and using it to sketch its momentary form against the dark, rich backdrop of the soil. The light moves slowly through the cellular water content, a quiet journey of photons completing their descent through a living lens, making the fairy lantern not merely an object in the light, but an almost silent conduit for the forest's gentle illumination, fading back into the earth as quietly as it appeared. 26. Fungi do not require sunlight for energy, instead drawing sustenance from the quiet decomposition cycles occurring in the rich, dark soil below. Fungi operate entirely outside the solar economy that dictates the life cycles of green plants. They possess no chlorophyll, demanding no energy from the swift, violent fusion reactions occurring 93 million miles away. Instead, their metabolic needs are met entirely through the slow, steady process of external digestion. They are the quiet recyclers, the decomposers whose life's work is the methodical breaking down of complex organic materials that have lived and now return to the earth. Within the dark, moist soil, the mycelium releases specialized enzymes, complex protein molecules designed to patiently dismantle the long, resilient chains of cellulose and lignin that form the structure of fallen wood and leaves. This enzymatic process occurs externally to the fungal body, a steady, low-energy biochemical reaction taking place in the microscopic film of water surrounding the organic matter. Once broken into smaller, digestible sugars and carbon compounds, these nutrients are then absorbed by the hyphal threads, fueling the slow, silent growth of the network. This reliance on decomposition anchors the fungal kingdom firmly to the earth, making it a critical pivot point in the carbon cycle. It is a tireless, continuous, and essential labor performed in absolute darkness, converting the static energy stored in dead matter back into bioavailable forms, ensuring that the quiet cycles of life and death maintain their perfect, measured rhythm beneath the cover of the forest. The fungi draw their energy not from the sudden burst of the sun, but from the deep, reliable continuity of decay. 27. The gentle cap surface of a russula often cracks in dry weather, creating a mesmerizing pattern of soft plates resembling old, dried clay. The russula mushroom, often possessing a brightly colored but inherently fragile cap, is highly susceptible to the subtle changes in atmospheric moisture. When a period of extended dry weather settles over the woodland, the cap's outer layer, the cuticle, begins to slowly lose its internal water content through evaporation. As the moisture leaves the cells, the surface tension increases, and the cap shrinks ever so slightly. However, the internal structure shrinks at a different rate than the tough outer layer, introducing a gentle, accumulating strain across the surface. When this tensile stress exceeds the elastic limits of the cuticle, quiet fissures begin to appear. These cracks do not occur randomly, but follow predictable lines of weakness, often forming a mesmerizing network of polygonal plates. The resulting pattern, known as areolation, mimics the structure of old, sun-baked mud or dry ceramic pottery. The edges of these newly formed plates curl slightly, revealing the pale, softer flesh beneath, creating a subtle contrast of color and texture. This quiet, structural adjustment is a defense mechanism, a passive response to desiccation, maximizing the area for surface cooling or perhaps simply accepting the inevitable geometry imposed by differential shrinkage. It is a transient beauty, the mushroom quietly etching the recent history of the weather onto its own cap, providing a detailed, temporary map of the atmospheric conditions before the next soft rain gently rehydrates the tissues and slowly softens the cracked topography. 228. When spores are forcibly ejected, they often travel at an imperceptible speed, relying on soft currents of air to carry them away from the parent body. The act of spore ejection, while characterized as a forceful action, is executed on such a minuscule scale that its speed is entirely relative and often invisible to the eye, maintaining the profound stillness of the woods. The mechanism, often involving a change in surface tension, or the rapid condensation of water vapor creating a minute ballistic impulse, is designed only to clear the immediate boundary layer of still air surrounding the gill or pore surface. The spore, possessing an almost negligible mass, typically measured in picograms, receives this quiet initial push. Yet this internal momentum quickly dissipates. The atmosphere is not a vacuum, and the tiny particle immediately encounters the resistance of air molecules, rapidly decelerating the spore until it effectively stops its forward movement almost instantly. From that point onward, the spore's vast journey is entrusted entirely to the gentle, subtle movements of the surrounding atmosphere. It becomes airborne, swept up by the faint, invisible currents of air that drift through the forest understory. It is carried by the slow eddies generated by temperature gradients, or lifted by the slight updrafts caused by the warming earth. The spore surrenders its own intention to the larger, constant flow of weather systems, moving quietly along the path dictated by the shifting wind, a silent, microscopic traveler relying on the slow, immense breath of the planet to fulfill its destiny of dispersal. 29. Rhizome mushrooms develop a smooth, shiny, varnish-like cap that quietly reflects the surrounding moisture and the dim, green forest light. The rhizome mushroom, often found attached to the lower trunks of decaying hardwood trees, cultivates a surface of remarkable stillness and luster. Its cap, technically known as the pileus, develops a thick, protective layer composed of complex resinous compounds, creating a finish that mimics the depth and sheen of dried varnish or polished wood. This surface is not merely shiny, it is deeply reflective, acting as a passive mirror to the soft environmental conditions. It quietly captures the diffused, often olive-toned light that filters down through the dense canopy above. The slightest presence of moisture, whether dew, condensation, or the lingering humidity of the air, enhances this reflective quality, making the cap appear wet even when dry. As the light photons strike this smooth, dark surface, they bounce back gently, creating an illusion of depth and permanence. The color reflected is often dominated by the muted greens and browns of the surrounding foliage and soil, anchoring the mushroom visually into its ancient, stable context. This varnish serves a critical biological function, repelling water and deterring minor insect infestation, ensuring that the slow-growing organism remains undisturbed across its long lifespan. The quiet contemplation of this mirror-like cap offers a visual metaphor for resilience, absorbing and reflecting the forest's dim light without fanfare, maintaining a poised, unwavering presence against the slow progress of decay that forms its very sustenance. 30. The stinkhorn mushroom emerges from an egg structure, slowly rising like a quiet, strange, netted dome through the damp forest floor. The stinkhorn begins its visible life encapsulated entirely within a protective, gelatinous sphere, often half buried in the soil, affectionately termed the egg structure. Within this moist containment, the preformed, condensed structure of the mushroom awaits the precise environmental signal, often a consistent period of warmth and sufficient moisture, to initiate its dramatic yet silent emergence. The actual process of rising is driven by immense but quiet hydrostatic pressure. The mushroom rapidly absorbs water, swelling its tightly packed cells, particularly within the stalk stipe structure. This absorbed liquid acts as an engine of expansion, forcing the internal tissues to stretch and elongate with remarkable speed, yet without any accompanying sound. The vulva, the outer skin of the egg, is gently but forcefully ruptured, allowing the strange, often phallic shape to ascend. Attached beneath the cap is often a delicate lace-like veil, known as the indusium or net, which unfurls as the stalk rises, draping itself like a soft, intricate dome over the structure. This silent, rapid emergence is a singular event in the fungal world, a quiet expression of stored biological energy pushing against the resistance of the earth. The entire process of expansion can take mere hours, yet it is performed with profound, deliberate slowness relative to the observer, a bizarre and beautiful biological unfolding that respects the deep quietude of the damp forest floor, leaving behind only the broken remains of its soft, protective shell. 31. Their cell walls are composed of chitin, the same gentle yet durable material found in the protective shells of slow-moving insects. This molecular structure lends a quiet resilience to the fungal form, allowing it to stand softly against the inevitable pressure of surrounding damp earth and the subtle movements of shifting soil. Chitin is a long, complex polymer, woven together in delicate yet firm crystalline threads, providing a scaffold that resists degradation while remaining flexible enough to accommodate the slow expansion of growth. One can compare this silent strength to the distant, rhythmic work of certain deep-sea creatures, whose exoskeletons endure the crushing weight of abyssal water, holding form against overwhelming force, yet requiring only the simplest metabolic energy to sustain. The chitin in the mushroom is a biological marvel of engineering, quietly protecting the internal structure and the delicate process of spore production from the disruptive effects of gentle breezes or the soft impact of a falling leaf. It speaks to a deep, underlying principle of nature where strength is not loud or abrasive, but rather a subtle, molecular persistence. The cells quietly arrange these components, ensuring that the fruiting body maintains its shape, perfectly positioned to complete its silent task before gently yielding back to the earth in its own slow, measured time. This material is a testament to the quiet efficiency of natural construction, supporting life in the shadows with an unhurried, steady strength that lasts exactly as long as necessary before softening and returning its components to the ongoing cosmic exchange. 32. The slow, silent decay they facilitate releases essential minerals back into the earth, nurturing future generations of plants and trees. This essential service is a crucial, patient component of the planetary nutrient cycle, conducted without hurry and far from the notice of the bustling world above. As the fungal enzymes softly break down complex organic matter, the fallen trunks, the dense cellulose of old wood, the quiet detritus of last season's leaves, they perform a meticulous alchemy. Carbon atoms, once locked tightly in lignin structures, are gently freed to rejoin the atmospheric breath or settle into the soil. Nitrogen, phosphorus, and potassium, vital elements for growth and life, are slowly rendered soluble, made available for the thirsty, waiting root tips of the towering forest trees. It is a system of quiet, constant giving back, ensuring that resources are never truly lost but merely transformed and placed into a different stage of the unending cycle. Imagine the centuries-long process of a single massive log returning to the soil, a process managed entirely by the unhurried work of these decomposers. They are the silent economists of the forest floor, managing the budget of life energy, guaranteeing the long-term fertility of the loam, and preparing the ground for the slow, upward surge of the next generation of silent, green giants. This patient decomposition is a lullaby of chemical transformation, a promise of perpetual renewal whispered softly to the fertile darkness beneath the surface. 33. Many small fungi grow only for a single night, quietly appearing under the full moon and melting back into the damp soil by the morning light. Their existence is a brief, ephemeral sigh in the vast timeline of the forest, a hurried biological event fueled by the deep reserves of their underground network. As the moon silently charts its path across the velvet dark, providing a soft, diffused illumination, the fruiting body surges outward, completing its life cycle in a rush of subtle growth. These are the quiet ghosts of the meadow, their delicate structures built quickly to disperse spores into the cool, still air before the atmosphere shifts. Once the morning sun begins its gentle ascent, introducing warmth and light back into the ecosystem, the delicate moisture balance that sustained the fragile structure begins to shift. Evaporation gently pulls the water from the thin tissues, and the ephemeral cap softens, its structure yielding to the physics of dissolution. It sinks quietly back into the dampness from which it arose, leaving behind only a subtle trace of moisture and a fresh distribution of invisible spores carried away on the first, soft breaths of the warming air. Their short presence is a reminder of the differing timescales of nature, where some lives are measured in the slow drift of continental plates, and others are measured in the quiet hours between twilight and dawn. A perfect, short-lived flourish of biological purpose. 34. Mycelial networks can spread across acres, holding the forest floor together in a silent, unifying web that stabilizes the entire ecosystem. This vast, subterranean matrix is the quiet, decentralized infrastructure of the woods, a continuous biological loom weaving together soil particles, root structures, and decaying matter into a cohesive whole. Imagine a map of fine, white threads stretching invisibly beneath the moss and pine needles, communicating the needs of one distant tree to another and transferring vital resources across spatial boundaries. This silent support system provides more than just nutrient exchange. It acts as a physical binder, mitigating the slow, persistent effects of erosion caused by flowing water and the slow creep of gravity down a slope. The earth, held together by this invisible stitching, remains stable, allowing the slow development of deep root systems and the steady accumulation of fertile humus. This pervasive network is an analogy for quiet community support, where the well-being of the whole relies upon the continuous, unseen efforts of its most fundamental components. It is a slow, steady demonstration of interconnectedness, functioning outside the hurried pace of the visible world, perpetually sustaining the forest's quiet equilibrium one microscopic thread at a time, ensuring that the ground beneath our feet remains firm and still. 35. The gentle curvature of a mushroom cap is designed to protect the fragile gill structure underneath from heavy dew and excessive splash damage. This architecture is a marvel of quiet, natural optimization, where form follows the necessity of silent dispersal. The smooth dome acts as a protective umbrella, subtly channeling the weight of collected moisture, whether from the slow condensation of night air or the sudden, heavy droplets of a brief shower, away from the delicate reproductive surfaces below. The gills, housing the millions of minute spores, must remain relatively dry and undisturbed so that the spores can be released effectively into the passive currents of the air. If the gills become saturated with water, the silent mechanism of spore ejection is compromised, and the reproductive cycle is briefly halted. Thus, the cap performs its function with quiet efficacy, managing the hydrology of its immediate environment. The precise slope and radius of the dome varies subtly across species, reflecting the specific environmental conditions each prefers, but the principle remains constant, a silent shield against the gentle yet persistent forces of atmospheric water, ensuring the quiet continuation of the species through gravity and air currents. 36. Sometimes, small insects use the underside of large caps as a quiet, temporary shelter from the sudden, heavy droplets of a light rain shower. These massive fungal structures provide an inverted canopy, a sudden, unexpected ceiling in the otherwise exposed landscape of the forest floor. A minute beetle or a resting fly, sensing the sudden change in atmospheric pressure that precedes a downpour, can quickly retreat to the sheltered, dry space offered by the cap's underbelly. Here, beneath the protective dome, the sound of the rain is transformed from a violent, random drumming on leaves and soil into a muffled, rhythmic patter above the sturdy chitinous roof. It is a silent refuge where the small creature can wait patiently for the storm to pass, observing the world from a place of dry safety. This temporary sanctuary is a simple, passive exchange of shelter for nothing, a quiet illustration of how the cycles of life and material provide unintended benefits across different biological kingdoms. The mushroom, rooted and still, offers stability and dryness, allowing the insect to conserve its minuscule energy reserves, patiently awaiting the return of the stable atmosphere necessary for its own slow movements across the wet, recovering forest floor. 37. Certain fungi form quiet associations with specific types of tree roots, showing a deep preference for their chosen, silent, underground partners. These mycorrhizal relationships are not random, but deeply etched into the biological history of the ecosystem, forming partnerships that have evolved over geological spans of time. The fungus quietly recognizes and seeks out the root chemistry of its preferred partner, whether it be the sturdy oak, the tall, resilient pine, or the slow-growing beech. This specificity is maintained through subtle, constant chemical signals, silent whispers exchanged between the root hair and the probing fungal hyphae. Once the association is established, the connection is one of mutual dependency, a quiet, internal economy. The fungus provides the tree with an extended root network, facilitating the slow uptake of distant water molecules and crucial trace minerals locked in the soil matrix. In return, the tree provides the fungus with the complex sugars produced silently through photosynthesis high above the forest floor. It is a relationship of deep, quiet commitment, essential for the stability and longevity of both organisms, conducted entirely in the cool, unhurried darkness below the surface of the earth. 38. The quietest sound a mushroom makes is the near-silent hiss of moisture evaporating from its surface as the morning temperature gently rises. This sound is generally imperceptible to the hurried human ear, a subtle chorus of water molecules transitioning into vapor, an ambient hum woven into the slow thermodynamics of the natural world. As the sun's warmth penetrates the canopy and begins to gently agitate the air surrounding the fruiting body, the surface moisture begins its slow ascent back into the atmosphere. This release is a function of the increasing vapor pressure deficit, a scientific description of the air's increasing thirst. The sound is less a hiss and more a continuous, soft dissolution, a sound wave so weak that it is often entirely masked by the quieter rustle of a single falling seed or the almost imperceptible sound of growing grass nearby. It is a biological breath, a way the mushroom regulates its temperature and internal pressure before it begins its own slow process of yielding back to the damp earth. This subtle acoustic event reinforces the deep quietude of the forest floor, marking the slow, steady exchange of water between the living organism and the vast, surrounding ocean of air. 39. They display an extraordinary array of soft, muted colors, ranging from gentle earth tones to pale yellows and soft, washed-out blues. These hues are not arbitrary but reflect the complex chemistry of the fungus, often derived from pigments synthesized to protect delicate tissues from the subtle damage of filtered sunlight, or to blend perfectly into their chosen environments of decay and shadow. The gentle earth tones, the soft browns, tans, and quiet ochres, provide perfect camouflage against the backdrop of decaying leaf litter and rich humus, allowing the fungal form to emerge and complete its reproductive cycle without drawing undue attention. The pale yellows often signal carotene compounds, a subtle echo of the sun's energy absorbed and utilized by the quiet metabolism of the cells. The rarer, washed-out blues and soft violets are often the result of complex molecular interactions within the tissue, shifting and softening as they react slowly to the oxygen in the surrounding air. The overall palette is one of deep subtlety and patience, colors that do not shout but rather whisper of geological time decay, and the slow, steady recycling of sunlight energy through the cool, damp pathways of the forest floor. 40. Slime molds, though not strictly fungi, move slowly and deliberately across wood, quietly seeking out new sources of energy in the shadows. This movement is a hypnotic demonstration of collective cellular decision-making, where the single-celled organism forms a massive, flowing sheet of protoplasm known as a plasmodium. It does not possess muscles or nerves, but rather navigates through internal chemical pulses, extending and retracting its pseudopods in response to subtle shifts in humidity and the faint chemical gradients emanating from potential food sources. This creeping motion is measured in millimeters per hour, an almost geologic pace of movement that requires patient observation to perceive. As the plasmodium advances across the damp log or the shadowed bark, it engulfs small particles of bacteria or yeast with a quiet, continuous flow. This entire process is silent, a slow, inevitable tide of life driven by the search for energy to sustain its simple, patient existence. The slime mold is a quiet study in biological persistence, relying on the universal laws of chemistry and physics to guide its slow, deliberate migration through the cool, dark, and often overlooked corners of the natural world, forever seeking the sustenance that will allow its cycle of quiet transformation to continue. 41. The subtle variations in humidity dictate where a spore will finally settle, allowing the mushroom kingdom to colonize a vast range of quiet niches, creating a precise map of moisture across the landscape. The invisible water molecules suspended in the evening air hold the key to the future forest floor, gently cushioning the descent of microscopic life. A spore, lighter than the finest dust, drifts on the breath of the planet, waiting for the perfect moment of saturation. If the air is too dry, it risks desiccation, simply falling inertly onto dry stone or brittle leaf litter, its journey ending prematurely in the harsh light of the morning sun, preventing the quiet initiation of new life. If the air is overly saturated, the spore might adhere too quickly to a neighboring surface, unable to find the nourishing substrate it truly needs for its quiet germination process to begin its long, slow work of decomposition and network building. Therefore, the spore relies upon the slow, rhythmic oscillation of atmospheric vapor, seeking out those tiny, protected pockets where the air remains consistently gentle and moist throughout the deepest part of the night, and where the disruptive flow of wind is minimized. These microclimates are often found nestled beneath the dense shelter of ferns, or resting against the cool, porous surface of decaying bark, places where the sun's demanding rays rarely penetrate, and the stillness of the air is paramount for settling. The forest floor becomes a finely tuned instrument, registering every shift in vapor pressure, guiding the fungal future with an invisible, aqueous hand, ensuring that life finds its softest resting place. This patient, slow settling is not chaotic, but an extremely detailed charting of the environment, a biological mapping conducted molecule by molecule, ensuring the quiet continuation of the vast, unseen network beneath the soil through careful adaptation. 42. A group of mushrooms appearing suddenly is sometimes called a troop, suggesting a quiet, organized gathering emerging from the unseen depths, a formation of biological entities rising in soft silence across the forest floor. The language used to describe these quiet appearances lends a sense of purpose and structure to the seemingly chaotic burst of life that follows a steady, soaking rain, likening them to a silent, temporary army fulfilling a singular duty. Though the term troop evokes images of ordered movement and shared mission, the organization is purely biological, controlled by the vast, interconnected network of hyphae operating patiently and steadily below the surface of the earth. The mycelium, which is the true body of the fungus, sends forth these fruiting bodies in unison when the environmental signals of moisture and temperature align precisely, signifying a moment of readiness and profound abundance after a long period of quiet accumulation. It is a slow, silent mobilization that seems quick only to the human eye, which misses the weeks of subterranean preparation, the steady gathering of energy and complex nutrients required for this collective emergence into the dim light. When the troop rises, they arrive quietly together, shoulder to shoulder in the damp moss, fulfilling the mandate of the unseen body to spread the spores widely and effectively before they gently fade back into the substrate, their mission complete. This collective timing suggests not aggression or sudden activity, but rather a coordinated efficiency, a shared biological clock ticking softly in the nutrient-rich darkness of the earth. They stand like silent, ephemeral sentinels, rising from the hidden geometry of the soil, confirming the strength and reach of the vast fungal kingdom that governs the slow decomposition of the forest and ensures the recycling of all matter. 43. The quiet, smooth stem of a button mushroom is designed primarily for elevation, lifting the cap just high enough for spores to catch the airflow, maximizing the dispersal distance with minimalist biological architecture. This gentle stalk, often pale and uniform in its structure, acts as a biological mast, pushing the reproductive structures away from the inhibiting boundary layer of still, humid air close to the damp ground where spore settling is inevitable. Gravity is a constant, subtle constraint, demanding that the stem be strong enough to resist buckling under the inevitable weight of the cap and the moisture it absorbs, yet efficient enough not to waste too much precious energy in dense tissue creation during its rapid growth phase. The resulting structure is a masterpiece of light engineering, typically hollow or filled with soft, loosely packed cells that provide structural support, offering stiffness without excessive mass or unnecessary expenditure of biological resource. As the cap opens, the delicate gills beneath begin their slow, rhythmic process of spore release, dropping their microscopic dust downward through the slight currents generated by temperature differences between the cool soil and the upper air. The exact height achieved by the stem is a critical evolutionary compromise. Too short, and the spores fall directly onto the immediate soil below, severely limiting their travel. Too tall, and the structure becomes vulnerable to swaying or snapping in the gentle breath of the passing wind. Thus, the quiet stem provides the perfect vertical clearance, ensuring that the liberated spores are caught by the slightest passing breeze, carrying the essence of the fungus far away, drifting softly toward new, uncolonized lands in the vast, still night. 44. Some wood-inhabiting fungi possess the ability to quietly change the color of the wood they colonize, leaving beautiful, stained patterns behind, weaving tapestries of decay and gradual transformation across the inner structures of the tree. This aesthetic alteration is not a conscious artistic choice, but a chemical side effect of the fungus, slowly breaking down the complex, rigid molecules that give wood its inherent structure and its uniform color. Enzymes, tiny biological workers, are secreted silently into the cellulose and lignin, systematically dismantling the rigid matrix and extracting the necessary carbon and nutrients required for the fungal body's own steady growth. As these complex chemical processes unfold over many slow seasons, they release various pigmented compounds that diffuse gently through the wood fibers, creating soft, swirling lines of blue, green, gray, soft black, and even muted pinks, depending on the fungal species. This natural coloring process is known as spalting, a painterly effect often prized by craftspeople and woodworkers who appreciate the delicate, unpredictable artistry generated by the quiet, essential march of decay across the material. The resulting patterns are unique to each piece of wood, dictated by the density of the grain, the precise pathways of water movement within the wood, the speed of the fungal growth, and the particular species involved in the decomposition process. This staining represents a quiet midpoint between life and death for the tree, transforming its rigid, uniform structure into a softer, more colorful medium that speaks of the gentle necessity of returning complex organic matter smoothly back to the Earth's slow cycles. 45. Many puffball species remain entirely round and subterranean until they mature, swelling silently beneath the soil before breaking the surface, patiently awaiting the precise moment for their dramatic dispersal across the surrounding environment. In the darkness below the protective layer of Earth, the puffball gathers its resources steadily, its tissues growing smoothly and continuously in a spherical form, which is optimally engineered for maximizing internal volume while minimizing the external surface area vulnerable to external pressures. This subterranean existence shields the developing fruiting body from the harsh drying effects of the sun and the immediate threats of foraging insects and small mammals, allowing for a long period of quiet, uninterrupted maturation in stable, moist conditions. The internal structure slowly transforms from dense tissue into a light, dusty mass composed almost entirely of millions of microscopic spores, preparing for the eventual moment of explosive release, storing the energy required for the break through the compact soil crust. As the final stage approaches, internal pressure increases steadily, subtly pushing against the weight of the overlying earth, a slow, gentle exertion of turgor that few creatures observe or register above ground. When the puffball finally breaches the surface, it often appears pale and smooth, a perfect globe of quiet potential, signaling its absolute readiness to complete its mission in the upper air. It sits then, waiting for a simple trigger, a light rain drop, the settling of evening dew, or the soft pressure of a passing hoof, to compress its structure and send its cloudy mass of spores floating gently into the upper atmosphere, a silent, sudden cloud of life emerging from the hidden depths below 0.46. The soft appearance of velvet shank mushrooms belies their cold tolerance, allowing them to quietly thrive even as the first gentle frosts arrive, painting the edges of the forest floor with crystalline, frozen beauty. While most fungal fruiting bodies prefer the warmth and heavy moisture of summer, utilizing the rapid metabolism that high temperatures permit, the velvet shank, or Flammulina velutypes, embraces the stillness and profound chill of the late year and early winter. This quiet resilience is due to complex biological adaptations at the cellular level, including the slow accumulation of specialized cellular compound that function as natural antifreezes, preventing the destructive formation of sharp ice crystals within their delicate internal tissues. They often emerge from the side of dead or dying trees, their slightly sticky, smooth caps contrasting sharply with their dark, velvety stems, which are specially insulated and protected against the dropping ambient temperatures. They grow slowly during this cold period, conserving energy and metabolizing at a much reduced rate compared to their summer counterparts, displaying a quiet patience that perfectly matches the hibernating, slowing world around them as the earth tilts away from the sun. When the surrounding world is withdrawing into winter silence, these fungi stand as small, brave, persistent reminders that life persists and finds its necessary niche, even when the sun's demanding warmth has retreated to the distant hemisphere. The gentle frost may crisp the leaves and harden the soil into temporary stillness, but the velvet shanks continue their silent, slow growth, fulfilling their quiet cycle long after the bright, bustling fungi of the warmer, more active months have dissolved back into the cool earth. 47. Fungi were traditionally classified as plants until scientists recognized their fundamental differences, granting them their own silent kingdom, a crucial, slow moment in the patient organization of biological knowledge and understanding. For centuries of simple observation, anything that was stationary, that lacked immediate, visible signs of locomotion, and that appeared to grow directly from the soil or wood was categorized instinctively alongside the rooted flora of the earth, a natural, if simplistic, grouping. The visible structures of the mushroom, the cap and the stem, seemed analogous to the flower and the stalk of a plant, leading to this initial quiet placement within the green kingdom of botany. However, as microscopic understanding deepened and biochemical analysis advanced, fundamental disparities emerged slowly, revealing the profound fungal truth that required a shift in perspective. Unlike plants, fungi possess rigid cell walls made of chitin, the same tough, resilient material found in the protective exoskeletons of insects, rather than the cellulose characteristic of plant life. More importantly, fungi are heterotrophs. They do not perform the miraculous alchemy of photosynthesis. They do not capture the sun's raw, immediate energy and transform it into sugar for sustained life. Instead, they must quietly acquire their nutrients by breaking down organic matter externally through secreted enzymes, absorbing the digested essence of their surroundings. This key metabolic difference demanded a separate classification, leading to the establishment of the kingdom fungi, a third great branch of eukaryotic life, dedicated to the patient work of decomposition, ruling over its vast, unseen subterranean network in quiet distinction from the bright, green world above. 48. The slow, rhythmic process of spore ejection can sometimes be correlated with gentle changes in atmospheric pressure and evening dewfall, demonstrating a deep, subtle sensitivity to the shifting conditions of the surrounding atmosphere and the movement of air masses. This microscopic release is an exquisite feat of microscopic hydrodynamics, often relying on the rapid condensation of a tiny drop of water, known as Buller's drop, to act as a physical catapult for the inert spore. This tiny droplet forms precisely near the spore, and as it swells due to the high humidity of the night air or the presence of evening dew, the resulting rapid change in surface tension launches the spore away from the gill surface with astonishing, unseen speed. When atmospheric pressure falls gently, often preceding a period of increasing humidity or soft, sustained rain, the conditions become optimally stable for the spore's necessary long-distance travel through the air currents, making this an ideal, biologically programmed time for dispersal. The mushroom is, therefore, a quiet, sensitive meteorologist, instinctively timing its most critical reproductive act with the optimal weather patterns dictated by the slow rotation of air masses and the cooling of the planet's surface during the night cycle. This sensitive correlation ensures that the spore is released not into dry, turbulent air, where it would quickly fall to the ground and fail, but into still, moist conditions where it can drift softly and patiently on the gentle currents, maximizing its chances of finding a welcoming destination far away from its immediate point of origin beneath the sheltering trees. 49. Some species possess caps that quietly dissolve or turn into a black, inky liquid upon maturity, returning their essence smoothly and completely to the ground, embracing a watery, fluid conclusion to their terrestrial existence. This remarkable, gradual process is called autolysis, or self-digestion, where the mushroom, having completed its reproductive function, releases powerful internal enzymes that systematically break down its own intricate cellular structure in a controlled, predetermined manner. The sturdy, fibrous cap gradually loses its firmness, collapsing inward upon itself and weeping a dark, viscous fluid that holds the countless spores in suspension, providing them with moisture for temporary mobility. This inky substance, often rich and velvety black in color, drips slowly downward onto the immediate surrounding soil, a controlled, deliberate melting that ensures the spores are deposited directly and gently onto the surface of the earth where they can begin their next phase. This dissolution serves a dual, quiet purpose. It prepares the reproductive structures for passive transport, allowing the liquid to slowly wick away through the soil or be gently disturbed by soft rainfall, and it eliminates the standing, temporary structure which has fulfilled its mandate. The mushroom achieves a final, soft fluidity, transforming itself from a rigid, visible form into a rich, nutrient-laden liquid, quietly closing its life cycle with a gentle, self-contained return to the primal dampness and organic matter from which it first emerged, ensuring nothing remains standing for long. 50. The gentle scent of specific fungi is used by small mammals to locate them beneath the soil, facilitating the spread of spores through foraging, linking the fungal kingdom to the warm-blooded world in a quiet, ancient partnership. These fungi, particularly those that form subterranean structures like the treasured truffles, release subtle volatile organic compounds, tiny airborne molecules that drift upward through the porous soil, reaching the sensitive olfactory receptors of small digging creatures, often guided by the deepest scent notes. The scent is often rich and earthy, designed through slow evolution to be highly attractive to squirrels, mice, deer, and other animals that engage in mycophagy. the necessary act of eating fungi for survival. This relationship is a quiet symbiosis. The mammal gains a vital source of complex nutrients, especially during the cold or dry seasons when other foods are scarce or unavailable, and the fungus gains a powerful, mobile dispersal system for its microscopic seeds. Once consumed, the tough, protected spores pass safely through the digestive tract of the animal, resisting the enzymatic breakdown, and are deposited far away from the parent organism, often enclosed in a small, nutrient-rich packet of waste that provides the perfect starting environment for germination. The small mammals thus become inadvertent, quiet gardeners of the forest, led by their keen noses and the gentle, hidden scent of the fungi, ensuring the slow, steady geographical expansion of the fungal network across the vast, slumbering landscape for generations to come. 51. Ghost pipe plants often depend entirely on the fungal network for nutrients, living a pale, silent existence in the darkest, undisturbed parts of the woods. This reliance is complete and absolute, a gentle agreement made deep within the shadowed earth where the sun's bright energy cannot reach the forest floor. The ghost pipe plant, often appearing translucent and ethereal, has forfeited the complex task of harnessing light and instead trusts in the slow, subterranean currents of energy managed by the sprawling fungal mycelium. This hidden network of hyphae stretches further than any visible root system, patiently mining the rich, decomposing debris, breaking down the tough cellulose and lignin that once held up the mighty trees overhead. Through this unseen, constant biochemical activity, the fungi absorb the vital sugars and minerals, and then, in an act of quiet, balanced exchange, they pass a portion of this nourishment directly to the ghost pipe. There is no urgency in this transaction, only the steady rhythm of necessity. The plant stands perfectly still, a silent white beacon against the dark mulch, patiently accepting the molecular gifts offered by its host, never needing to green its leaves or reach actively toward the sky. It lives entirely within the humid equilibrium of the forest floor, participating in a highly specialized dance of dependency, one of the forest's deepest, most reserved secrets. The energy moves softly, flowing through microscopic threads, a current invisible to the eye yet powerful enough to sustain life in the profound, quiet darkness, reflecting the gentle, balanced nature of all essential natural cycles, much like the slow, reliable orbit of distant planets. This symbiotic relationship operates outside the usual bounds of solar capture, proving that life finds its soft, steady way even when the most fundamental energy source is deliberately ignored. 52. The delicate ring, or annulus, found on the stem of certain mushrooms is the quiet remnant of the protective veil that covered the gills when the fungus was young. This subtle structure is a peaceful marker of maturity, a gentle label denoting the passage from protected infancy to spore-releasing adulthood. When the mushroom first emerges from the earth, or from the wood, its fertile underside must remain shielded from the air and from stray contaminants, ensuring the perfect, quiet development of the spore-producing basidia. The thin veil holds this space, a taut membrane stretched between the edge of the cap and the stem. As the fungus slowly expands, driven by the steady intake of moisture and the relentless hydrostatic pressure of cellular growth, the cap begins to unfurl, like a very slow umbrella opening over days. The internal pressure gently tears the veil away from the cap margin. This rupture is not violent but a soft, gradual separation, and the small frill that often remains clinging to the stem is the resulting annulus. It is a quiet historical artifact, a silent memory of the mushroom's youth, now simply riding the stem as the final structure reaches its full height, poised for the silent descent of spores. This ephemeral ring, sometimes thick and skirt-like, sometimes just a thin, dusty band, exists solely as a testament to the growth cycle, a piece of biological evidence left behind when the necessity of protection gives way to the function of dispersal. It catches the light softly, reminding the careful observer that every stage of existence leaves its soft, structural trace, like the quiet erosion of ancient stone by steady, flowing water. 53. Fungi can slowly colonize fabrics and paper in quiet, damp environments, subtly reclaiming manufactured materials back into organic material. This steady, unassuming process is nature's ultimate patient recycler, working silently in the still air of neglected places. The tiny fungal spores, perpetually drifting on the soft air currents, settle upon cellulose-rich substrates like linen, cotton, or old paper documents. Provided with the necessary stillness, the consistent humidity, and the lack of disturbing light, these spores germinate, sending out microscopic hyphae. These threads weave their way through the tightly packed fibers, secreting specialized enzymes that slowly, relentlessly break the long cellulose chains into simpler sugars. There is no rush in this work. It is an act of quiet, continuous chemistry, reversing the labor of human hands that once spun and pressed these materials. Over weeks and months, the material loses its structural integrity. Paper becomes brittle and stained, the ink bleeding softly into the spreading fungal colonies. Fabric grows tender, developing soft patches of discolored mold, returning the organized structure of the cloth back toward the disorganized complexity of the earth. This process highlights the enduring stability of natural cycles. Nothing manufactured truly escapes the slow, inevitable pull back into the organic pool. The fungi perform this task without sound or speed, patiently dissolving the boundaries between the natural and the artificial, ensuring that every fiber, every molecule, eventually rejoins the slow, steady flow of the planet's silent metabolism. 54. The process of mycelial fusion, where two different strands meet and merge, happens silently and invisibly, creating a stronger, unified network beneath the cover of the soil. This merging is a profound biological act, an acceptance of difference leading to increased robustness and expanded reach. When two compatible hyphal strands encounter each other in the moist darkness, they engage in a soft, cellular negotiation, recognizing molecular markers on their surfaces. If compatibility is confirmed, the cell walls at the point of contact slowly dissolve, and the cytoplasm, the internal fluid holding the cell's components, flows together, joining the genetic material and integrating the separate structures into one cohesive organism. This quiet fusion is termed anastomosis. It ensures genetic mixing and allows the resulting network to share resources and communicate over vast, silent distances underground, increasing the colony's resilience against localized drought or resource depletion. There is no struggle in this joining, only the quiet, biochemical imperative toward cooperation and stability. It is a metaphor enacted in the hidden world of the soil, the necessity of connection for survival. The resulting unified mycelial net can span acres, transporting nutrients and water with greater efficiency. A continuous, living highway built through the patient merging of individual paths. This process is a testament to the powerful, unifying forces found in nature, similar to how distant stars slowly draw together through the subtle, persistent work of gravity across the vast, empty quietude of space. 55. Many edible mushrooms have lookalikes, demanding quiet, careful observation of subtle details like gill attachment and color changes when bruised. Foraging requires an absolute stillness of mind and body, slowing down the frantic pace of human thought to match the deliberate pace of natural growth. The difference between a nourishing meal and a toxic encounter often rests upon minute features, the slight nuance in the hue of a spore print, or the specific way the gills meet the stem, whether they decur, running softly down the stalk, or are free, pulling away cleanly. A true forager learns to observe with a quiet intensity, noting the precise texture of the cap, feeling for the shift from damp to dry, and gently pressing the flesh to witness the slow, revealing chemical reaction of bruising. Some harmless species bruise soft brown, while dangerous counterparts might bleed an alarming blue or a fleeting purple hue, a silent signal of hidden compounds. This observation demands patience, often requiring the subject to be carried home and watched over hours, noting the inevitable passage of color and texture as it dries or cools. It is a practice in humility, acknowledging that the earth holds secrets that are revealed only to those who approach with slow reverence and quiet dedication. The subtle differentiation of species, dictated by ancient, specific genetic codes, requires the human observer to shed haste and embrace the deep, silent focus of a naturalist studying a perfect structure under the dappled light of the forest canopy, knowing that the smallest detail holds the greatest importance. 56. The texture of a mature cap often shifts subtly from smooth to velvety, marking its slow, patient passage through different stages of growth, influenced by the environmental air currents and the steady absorption of moisture. When the mushroom first pushes through the soil, the cap is usually tightly packed and moist, its surface smooth like polished porcelain due to the hydrostatic pressure within its cells and the protective layer of slime, or viscid coating. But as the cap expands toward its final diameter, and as hours pass under the influence of the sun and the dry air, that internal pressure normalizes and the surface cells begin their slow, final differentiation. The smooth, shiny skin often starts to dry, and the fine structures of the cellular outer layer become more prominent, giving the cap a soft, suede-like or velvety feel. This textural shift is a sensory marker of time, a quiet tactile record of the fungus responding to its external environment. A velvety cap suggests a slight maturity, perhaps a period of stable weather where drying occurred slowly and evenly. The texture absorbs the light rather than reflecting it sharply, creating a deeper, softer hue in the twilight. It invites a gentle touch, a connection that acknowledges the end of the rapid growth phase and the beginning of the spore release cycle. This transformation is entirely passive, the result of physics and cellular expansion meeting the slow, inevitable movement of air and the gentle withdrawal of surface moisture. Much like how soft velvet is made from countless tiny, light-absorbing fibers. 57. In ancient times, mushrooms were often associated with secret, quiet knowledge due to their sudden appearance seemingly overnight after a rain, fostering a sense of mystery and connection to the unseen world. Unlike familiar plants that visibly grow, pushing leaves and stems toward the sun over weeks, the fruit bodies of fungi materialize with astonishing speed following a period of deep, soaking moisture. This quick emergence suggested they were born of hidden forces, perhaps lightning strikes, or the concentrated dew of the heavens, or whispered secrets of the earth spirits. The widespread mycelial network, having been patiently accumulating resources beneath the soil for months or even years, only waits for the precise trigger of saturation and temperature change. Once the signal is received, the preformed primordial structures swell rapidly with absorbed water, pushing upward against the resistance of the earth. This quiet internal pressure builds rapidly, resulting in the appearance of a substantial, often complex form where none was visible the day before. Because this crucial preparatory work is entirely hidden from human sight, the result feels miraculous and sudden, lending the mushroom an aura of quiet, potent magic. They were often viewed as messengers from the underworld, temporary manifestations of ancient wisdom, emerging in the stillness of the dawn after the night's heavy downpour had ceased, carrying secrets about life, decay, and the cyclical nature of existence, secrets that only the silent forest truly understood. 58. Some tropical fungi glow brightly enough to read by, creating fleeting, gentle pools of ambient light in the humid, hushed jungle undergrowth, a phenomenon known as bioluminescence. This soft, otherworldly glow is produced through a quiet, cold chemical reaction involving specialized compounds like luciferin, catalyzed by an enzyme called luciferase. Unlike fire or electrical light, this bioluminescent emission produces no heat, existing purely as a soft, greenish-blue illumination that permeates the deep darkness of the perpetually damp forest floor. The light flickers gently, often strongest around the edges of the decaying wood or soil where the fungal hyphae are most actively breaking down organic material. This steady, non-violent light creates a temporary map for certain night-active insects, potentially attracting them to aid in spore dispersal across the thick, still air. Walking through such a jungle at night is to witness an entirely silent constellation laid low upon the earth, a reverse sky where the light does not shine down but emanates subtly from the deep, rich soil. The air is heavy and still, muffling all sound, allowing the visual experience of this soft light to dominate the senses. It is a slow, rhythmic chemistry at work, fueled by the energy stored in dead matter, reminding the observer of the hidden, gentle power latent within the cycle of decomposition, illuminating the profound quiet of the equatorial night. 59. The quiet persistence of bracket fungi allows them to live for many years, slowly adding new growth layers much like the rings of a tree, firmly anchoring themselves to the trunks of living or fallen hosts. These shelf-like fungi, also known as polypores, exhibit a profound longevity, often enduring decades by patiently accumulating material season after season. Each year, as conditions become favorable, usually marked by consistent warmth and moisture, the fungus adds a new layer of tissue to the underside and perimeter of its existing structure. These additions are slow and steady, forming dense, woody increments that become permanently fixed to the host. When the bracket fungus is carefully sectioned, these layers reveal the history of the organism, much like dendrochronology reveals the history of the tree. A thick layer speaks of a year of abundant rain and mild temperatures, while a thin, compressed layer might signify a harsh, dry season or a period of dormancy. The bracket fungus does not hurry. Its existence is one of slow, quiet accumulation and unwavering adherence. It stands firm against the wind, the snow, and the steady decline of its host, acting as a slow, visible clock marking the passage of time in the forest, a patient monument to biological stability. This persistence ensures its role as a dedicated, long-term recycler, slowly breaking down the tough wood over many years, performing its essential, quiet work across the shifting landscape of the seasons. 60. The process of fungal respiration releases minute amounts of carbon dioxide back into the atmosphere in a steady, silent environmental exchange, contributing subtly but significantly to the global climate cycle. All living organisms respire, taking in oxygen and releasing carbon dioxide, but the sheer volume and continuous activity of the fungal network beneath the earth mean this subtle exhalation is vast and constant. As the mycelial threads break down complex organic molecules, the remnants of leaves, roots, and wood, they require energy, which is gained through this respiration. Carbon atoms, previously locked securely within the rigid structures of the dead biomass, are chemically recombined with oxygen, forming the familiar CO2 molecule. These tiny, invisible molecules then slowly diffuse upward through the porous soil, eventually joining the vast, circulating currents of the atmosphere. This exchange is essential for balancing the planet's carbon budget, acting as the quiet counterpoint to the powerful carbon sequestration performed by living plants through photosynthesis. There is no noise associated with this molecular liberation. It is the silent breath of the decomposition engine, a constant, steady release that underscores the cyclical nature of all terrestrial matter. This fungal contribution is part of the deep, slow rhythm of the planet, an unseen force that manages the atmospheric balance across continents and centuries, ensuring that carbon remains mobile and available for future generations of life. 61. Many mycorrhizal fungi quietly enhance the ability of host plants to absorb water and necessary minerals from the sometimes challenging soil. This unseen collaboration unfolds beneath the surface of the earth, far removed from the hurried movements of the sun and the wind. The fungal filaments, known as hyphae, spread out in a silent network, extending the reach of the plant's roots exponentially, like quiet, endless tributaries flowing into a main river system. They explore micropockets of soil that the larger, coarser root hairs cannot access, retrieving vital elements such as phosphorus and nitrogen, which are often locked tightly within the Earth's structure. This symbiotic exchange is a cornerstone of forest ecology, a slow, gentle trade where the fungus receives carbohydrates, the sugars created by the host plant through the steady process of photosynthesis in the quiet light above. The mycelium acts as a vast, efficient pipeline, delicately pulling water molecules through the soil matrix, defying the subtle resistance of friction and gravity. It is a slow, constant transfer of energy and matter, sustaining the silent respiration of the forest through dry seasons and times of mineral scarcity. This underground cooperation ensures the stability of the entire ecosystem, a biological safety net woven from microscopic strands, ensuring the patient, steady growth of even the largest, most ancient trees. The quiet persistence of these partnerships reminds us that the most crucial processes often occur without sound, relying instead on the subtle laws of chemistry and biological rhythm. The gentle hum of life is maintained by these invisible helpers, always working slowly, always working in concert with the quiet cycles of the Earth's crust and the deep water table. 62. The gentle, almost cotton-like texture of certain species suggests a deep softness, inviting a careful, quiet touch upon the forest floor. This tactile quality is a reflection of the rapid yet controlled growth of the tissue, composed of countless cellular strands woven together with minimal structural density. When light filters down through the dense canopy, it is absorbed softly by these pale, yielding surfaces, creating shadows that are indistinct and blurred, matching the quietness of the surrounding air. To touch this texture is to feel the cool, steady humidity of the earth itself, a transfer of the temperature maintained beneath the leaf litter. The lightness of the structure is a testament to its composition, primarily water and simple chitin, lacking the rigid lignin structures found in woody plants, allowing for a fleeting, ephemeral presence in the landscape. This softness is part of the natural cycle, preparing the structure for its eventual, quiet dissolution back into the soil, where its cellular material will be slowly broken down by subsequent generations of microbes. The surface acts as a subtle dampener of sound, absorbing the slightest vibrations, reinforcing the deep stillness of the forest floor, a place where only the rustling of microscopic organisms continues their endless work. This quiet, gentle yielding stands in opposition to the sharp edges and rough textures of the mineral world, providing a momentary cushion against the hard realities of rock and root, encouraging a slow, respectful pause in the observation of nature's delicate forms. 63. Spores are so minute that they often resemble fine, pale dust when accumulated, sometimes creating a quiet, temporary cloud around the cap. These tiny reproductive units are the result of meticulous biological engineering, designed for maximum lightness and aerial transport, relying entirely on the slow, invisible currents of air or the subtle pull of gravity. When disturbed, the collected spores lift into the atmosphere, catching the light in a momentary, silent dispersion. They drift like microscopic cosmic travelers, obeying the physics of fluid dynamics, suspended on the breath of the earth. Each spore contains the quiet blueprint for a vast potential network, yet the probability of any single spore landing in the perfect, nutrient-rich environment required for germination is infinitesimally small, a slow game of chance played out across geological time. The creation of this dust cloud is a final, quiet act of the fruiting body, ensuring that thousands of possibilities are launched into the environment, relying on sheer numbers to guarantee the persistence of the species. Watching the pale haze settle back down is a lesson in patience and scale, recognizing the immense quantity of life necessary for future generations to quietly take hold. The movement of the dust is inherently calming, a slow descent dictated by the steady, unyielding influence of gravity, ensuring that all matter eventually returns to the quiet surface of the soil from which it arose, ready to begin the cycle, a new point 64. Some fungi possess medicinal properties, offering quiet, gentle aid through compounds developed during their long, patient subterranean lives. These complex molecules, often serving as defense mechanisms against competing microbes in the dense, dark environment of the soil, represent years of slow, silent biochemical refinement. The subterranean world is a place of constant microbial competition, where survival is predicated on the steady production of subtle chemical signals and inhibitors. The fungi, operating in the absence of light and the rapid temperature fluctuations of the surface, invest their energy into these complex, aromatic compounds. When utilized, these extracts introduce a gentle, modulating influence into the biological systems of other life forms, promoting balance and quiet repair. This ancient knowledge of using the Earth's quiet chemistry for restoration spans centuries, linking the slow growth cycles of the deep Earth to the delicate equilibrium of living physiology. The resulting medicines are not abrupt in their action, but rather offer a slow, steady encouragement towards cellular harmony, reflecting the deliberate pace at which they were created. They are the concentrated essence of underground patience, offering a quiet reminder that the most profound healing often comes not from sudden intervention, but from the slow, steady influence of naturally evolved molecular structures, patiently waiting in the quiet dark for their moment to offer gentle aid. The fungi are quiet pharmacologists, perfecting their craft over millennia beneath the silent watch of the roots and rocks. 65. The way a stem attaches to the cap, whether centrally, laterally, or slightly off-center, is a quiet, unique feature of its specific identity. This subtle architectural detail is dictated by the genetic codes that govern cellular expansion and the response to environmental forces, particularly the gentle but constant tug of gravity. A centrally attached stem suggests a quiet, symmetrical growth pattern, optimizing stability and balance, much like the slow, steady rotation of a perfectly round celestial body. A lateral attachment, where the stem joins the cap near the edge, indicates a more resourceful growth response, often found in species growing horizontally on wood or dense substrate, optimizing their structure to counter asymmetric weight distribution. This placement is a quiet, morphological adaptation to the specific stresses placed upon the organism by its substrate and orientation. Observing this feature requires a quiet, careful attention to detail, recognizing that these minor variances in geometry hold profound significance in the classification and life history of the species. It is a slow lesson in biological geometry, where the placement of a single supporting axis determines the overall silhouette and quiet persistence of the fruiting body against the background of the forest floor. These structural choices are finalized during the rapid, yet meticulous, expansion phase of the mushroom, demonstrating nature's quiet adherence to optimized design based on the physical laws that govern all growth and form. 66. Ghost fungi primarily rely on insects and mites to gently carry their spores away, utilizing these small travelers in their reproductive cycle. This interaction is not dramatic, but a quiet, passive exchange happening on a microscopic scale within the leaf litter. The fungi often develop subtle structures or compounds that attract these tiny arthropods, encouraging them to traverse the gill or pore surfaces where the spores are silently produced. As the mites and insects navigate the complex topography of the fruiting body, the minute, dust-like spores adhere quietly to their legs, antennae, and exoskeletons, a form of biological hitchhiking that requires no conscious effort from the fungus itself. These tiny carriers then continue their slow journey through the damp environment, gently depositing the spores miles away, ensuring a wider, quieter dispersal than could be achieved by mere air currents alone. The insect acts as an unconscious vector, participating in a vast, slow-moving biological mandate. This reliance demonstrates the intricate, quiet interconnectedness of the forest ecosystem, where even the smallest creature plays a crucial, though unwitting, role in the larger cycles of reproduction and decay. It is a gentle, steady process, governed by the attraction of scent and the simple movement of microscopic feet, ensuring the quiet continuance of the species across the wide, still expanse of the forest floor. 67. Certain fungi react to being gently bruised by slowly changing color, signaling their internal chemistry through subtle, quiet oxidation processes. When the cellular wall is breached by the softest pressure, specialized internal compounds, often clear or faintly colored, are exposed to the ambient oxygen in the air. This exposure initiates a slow, steady chemical reaction, transforming the molecular structure of the compounds, a process akin to the slow rusting of iron, but contained within living tissue. The resulting hue, often a quiet blue, deep yellow, or dusky purple, spreads slowly across the injured area, a gentle stain marking the place where the structure was disturbed. This color change is not a sudden, alarming display, but a gradual deepening that requires patience to observe fully, a visual representation of internal molecular movement settling into a new, stable chemical state. It is a quiet, internal dialogue with the atmosphere, revealing the hidden chemical architecture of the organism without sound or rapid movement. This slow signal of oxidation serves as a quiet warning to larger organisms that might seek to consume it, a silent language spoken through the gentle shifting of light wavelengths absorbed and reflected by the newly formed molecules. The transformation happens without haste, mirroring the slow, deliberate pace of all chemical events governed by thermodynamic equilibrium. 68. The largest living organism known is often a vast mycelial network, quietly existing across thousands of acres beneath the forest surface. While the visible mushroom is fleeting and ephemeral, the true body of the organism persists in the form of these fine, white threads, slowly permeating the soil matrix. This vast network is not a single, solid mass, but an endless, decentralized web of hyphae, communicating chemical messages across vast distances beneath the quiet shield of the Earth. Its growth is imperceptibly slow, measured in geological time rather than seasonal cycles, expanding patiently through the constant, low-energy process of seeking and absorbing nutrients. The sheer scale of this organism demonstrates a mastery of quiet, persistent energy management, utilizing the steady decay of woody debris as its slow, sustained source of fuel. Comparing this vast network to the slow creep of tectonic plates or the silent pressure of deep ocean currents helps to appreciate its hidden, immense scale. It is a quiet, powerful presence underlying the entire forest, coordinating resource allocation and communication across acres of seemingly disconnected plant life. The fruiting bodies that appear above the surface are merely small, occasional signals of the massive, quiet entity that maintains its continuous, unhurried existence in the perpetual dark below, reminding us that the greatest forms of life are often those that move and grow the slowest. 69. They often flourish in the quiet corners of the world, thriving away from direct disturbance, such as under logs or deep in dense leaf piles. These quiet microclimates offer optimal conditions for steady, uninterrupted growth, shielded from the drying effects of direct sun and the scouring action of strong winds. The leaf litter and decaying would create an insulating blanket, maintaining a stable temperature and, crucially, a high level of humidity, essential for the delicate, water-intensive metabolism of fungal growth. In these sheltered pockets, the quiet work of decomposition proceeds at a constant, steady pace. The slow breakdown of complex organic molecules releases the necessary nutrients without the sudden disruptions of surface events. This preference for stillness highlights the organism's requirement for predictability, It relies on stable, dark conditions to carry out its silent, biochemical duties without interruption. The quietude of these hidden spaces allows the fungal network to expand systematically, weaving its strands through the substrate with a slow, deliberate efficiency. These are the forgotten sanctuaries of the forest, where the noise of the day fades into a deep, sustained silence, allowing the patient, quiet cycles of nature to continue their essential, unhurried work beneath the soft covering of gathered debris and fallen branches, supporting the foundation of the entire ecosystem. 70. Many species exhibit perfect bilateral symmetry, showcasing nature's quiet adherence to balanced and aesthetically pleasing structural design. This symmetry means that if a line were drawn down the center of the cap and stem, one half would be a precise, quiet mirror image of the other. This structural perfection is not accidental, but an evolutionary optimization, ensuring that weight is evenly distributed and that the maximum surface area for spore dispersal or gas exchange is achieved efficiently. It reflects the fundamental physical constraints imposed by gravity and the biological imperative for efficient resource management. This quiet adherence to balance is observed throughout the natural world, from the crystalline structure of snowflakes to the orbit of silent planets, all governed by underlying mathematical principles. For the fungi, achieving bilateral symmetry during the rapid expansion phase requires precise cellular coordination, a quiet, internal process guided by genetic programming. The resulting form is inherently soothing to observe, providing a visual sense of stability and proportion amidst the chaotic randomness of the surrounding leaf litter. The balanced structure suggests a peaceful equilibrium with the environment, a quiet confirmation that even in the transient life of a fruiting body, the deep, unchanging laws of physics and geometry are always quietly, steadily upheld. 71. The quiet clicking sound sometimes associated with spore release is often too soft for the human ear to register without highly sensitive equipment. The forest floor settles into a profound stillness, a deep quiet broken only by the steady rhythm of faraway breathing wind moving through the high canopy. Within this immense silence, a universe of minute actions unfolds, actions governed by the precise physics of surface tension and molecular exchange. The release of a single fungal spore is an event of ballistic precision, often requiring a minuscule droplet of water, known softly as Buller's drop, to coalesce upon the spore's surface. As this drop grows, it shifts the center of gravity, and when it merges with a second adjacent droplet, the resulting sudden release of energy, though almost infinitesimally small, provides the needed thrust to launch the spore away from the gill surface and into the surrounding air currents. This mechanical event, the rapid change in water structure and release of hydrostatic energy, creates a sound wave. It is a soft, brief snap, a whisper of physics happening at the limit of scale. These millions of synchronous, yet individual, launches create a cumulative sonic landscape, yet one that vibrates at frequencies and amplitudes far below the human threshold for casual perception. Specialized microphones, shielded against the rumble of the earth and the slow movement of air, are required to gently listen to this quiet orchestration. The sound is a confirmation of life's steady propagation, a delicate drumbeat of dispersal occurring continuously in the dark and damp, unheard by the passing creatures above. It is a comforting thought that the universe is so filled with purpose and function, operating steadily even in the profound absence of audible noise, requiring only patience and highly sensitive technology to perceive the silent, ceaseless work of nature's micromachines performing their essential duty of continuation. 72. Some fungi possess a unique, universal veil that breaks quietly as the mushroom expands, sometimes leaving soft, patchy remnants on the cap. Deep within the damp earth and decaying material, the young mushroom begins its ascent, enclosed first within a protective structure often described as the universal veil. This structure is a thin, membranous casing, formed early in the fungus's development, designed to cradle and safeguard the emerging cap and the delicate gill structure, while it waits for the perfect environmental cues, the right temperature, the steady infusion of moisture. The mushroom embryo, contained within this soft cocoon, grows slowly but with inexorable pressure, expanding cell by cell, absorbing water from the surrounding humid air and damp substrate. This growth generates a subtle internal stress against the taut surface of the veil. When the moment arrives for the cap to fully unfurl and present itself to the world above the soil, the veil cannot hold the swelling form any longer. It yields gently, tearing along lines of least resistance, not with an abrupt sound but a quiet, cellular separation, a sigh of biological release. As the cap expands, the fragments of this protective layer are often dragged upwards. Some pieces remain delicately adhered to the surface of the cap, forming soft, temporary patches or flecks, like small, pale islands upon the dome. Other parts may fall away, forming a cup or volva at the base of the stalk, quietly softening back into the soil matrix. These remnants serve as transient markers, visual evidence of the hidden history of the mushroom, telling the story of its journey from a protected embryo to a fully mature fruiting body, ready now to perform its task of spore distribution before the gentle processes of gravity and erosion slowly dissolve the temporary markings. 73. They quietly draw sustenance from dead organic matter, preventing the forest floor from becoming eternally cluttered with woody debris. The great stillness of the forest floor relies upon a constant, slow dismantling process, a quiet architectural reorganization orchestrated by the decomposers. Fungi are essential actors in this ceaseless work, employing vast, intricate networks of hyphae that spread unseen through the soil, penetrating the structure of fallen logs and branches. They do not consume in haste. Rather, they perform a measured chemical alchemy. By secreting specialized enzymes, the fungi slowly unlock the complex, highly durable molecules of cellulose and lignin, the primary components that give wood its inherent strength and rigidity. This digestive process is slow, often taking years or decades to complete, yet it is relentlessly steady. The fungi quietly draw sustenance from these liberated carbon chains, channeling the necessary energy for their own growth and fruiting. In doing so, they prevent the endless accumulation of debris, ensuring that the forest floor is not permanently cluttered with the woody skeletons of past generations. This systemic recycling is fundamental to the health of the entire ecosystem. The carbon and nutrients previously locked in the rigid structure of the dead tree are gently returned to the soil solution, making them available once more to the living plants and creatures nearby. It is a slow, powerful demonstration of material transformation, where nothing is truly lost, only patiently repurposed, maintaining a gentle, sustained flow of energy through the cycles of growth, rest, and renewal, all performed in the quiet, deep shade beneath the canopy. 74. The smooth, flowing shape of certain fungi helps guide rainwater away from the gills, ensuring the delicate spore-bearing structures remain dry. The architecture of the mushroom cap is a marvel of passive hydraulic engineering, finely tuned by millennia of interaction with the natural elements. Consider the gentle curve and the subtle slope of a mature fungal umbrella. This shape is not arbitrary. It is designed to manage the flow of moisture with quiet efficiency. When soft rain descends, the water droplets encounter the smooth, often slightly waxy surface of the cap. Surface tension and the influence of gravity then take over, guiding the water molecules along the path of least resistance. The curved slope encourages the water to sheet gently outward, running smoothly along the radius toward the rim. This careful channeling ensures that the crucial gill structures, situated beneath the cap and bearing the microscopic spores, are shielded from direct impact and excessive saturation. If the gills were to become waterlogged, the delicate mechanism of spore release, which often relies on precise ballistic launch from a dry surface, would fail. Therefore, The shape acts as a constant, silent guardian, maintaining a microclimate of necessary dryness underneath the protective awning. This smooth, flowing form is an elegant solution to a fundamental ecological problem: how to grow and reproduce in an environment defined by humidity and rainfall, demonstrating nature's quiet preference for simple, efficient geometries that maintain biological function through the gentle and predictable forces of physics. The shape allows the cycle of life to continue, quietly diverting the power of the rain while benefiting from the nourishing moisture the earth provides. 75. Certain tree species will not establish without the quiet, collaborative presence of their necessary fungal partner nearby. In the soil, the forest ecosystem is built upon hidden collaborations, whispered agreements beneath the surface that determine the very possibility of life for many of its inhabitants. Among the most fundamental of these partnerships is the mycorrhizal association, a quiet interdependence between the expansive root systems of trees and the pervasive mycelial networks of certain fungi. Many dominant tree species, particularly those of the temperate and boreal zones, cannot thrive, and sometimes cannot even begin to grow from seed, without their specific fungal counterpart nearby in the soil solution. The fungal hyphae, far finer and more numerous than the plant's own root hairs, effectively extend the tree's reach, acting as microscopic conduits that permeate the soil matrix. They quietly scavenge for essential immobile nutrients, such as phosphorus and critical trace minerals, which the tree's roots struggle to absorb efficiently. In exchange for this vital delivery service, the tree, a master of photosynthesis, generously transfers surplus sugars, the energy derived from sunlight, down to the root zone, sustaining the hungry fungal partner. This continuous, silent exchange establishes the very foundation of the forest, ensuring robust uptake of water and nutrients, and conferring a greater resilience against environmental stresses. The growth of the great trees, their slow reach toward the sun, is quietly predicated on this unseen cooperation below ground, a testimony to the essential nature of biological partnership in achieving stability and enduring life. The seed rests, waiting for this necessary, quiet ally to weave its supportive net before daring to push its first fragile shoot toward the light. 76. The ephemeral nature of many mushrooms means they exist only briefly above ground, returning their moisture and form quickly to the damp earth. The life cycle of many mushrooms is a study in brevity and quick transformation, while the true body of the fungus, the extensive mycelial network, persists unseen deep within the substrate. The familiar fruiting body that rises above ground is designed for a transient existence, a focused moment of reproductive efficiency. Following a heavy rain or a sudden shift in humidity, the mushroom emerges, swelling rapidly with absorbed moisture, often over the course of just a few hours or a single night. This sudden appearance is a biological imperative, a rapid deployment engineered to release spores into the atmosphere before environmental conditions shift again. Once the spores are launched, or once the brief window of optimal weather closes, the mushroom's purpose is fulfilled. Its structure, composed mostly of water-filled cells, immediately begins its quiet decline. Gravity, microbial action, and the slow process of evaporation begin to reclaim the material. The cap softens, the stalk collapses, and the rigid form loses its definition, melting back into the damp earth almost as quickly as it appeared. It is a graceful and swift retreat, a return to the source. This ephemeral existence teaches a quiet lesson about efficiency. All the necessary structural complexity needed for reproduction is created, utilized, and then dissolved, ensuring that the valuable components are quickly reintegrated into the soil, ready for the next cycle. The mushroom is a fleeting visitor, a momentary expression of the persistent life force hidden below, offering its brief beauty before consenting to the inevitable return to damp, nourishing oblivion. 77. Many caps have small scales or tufts of material, which adds soft texture and helps slow the speed of raindrops hitting the delicate structure. Upon close inspection, the surface of many mushroom caps reveals a subtle tapestry of texture, small scales, gentle tufts, or delicate fibrils that break the smooth plane. These minute structural details are not merely aesthetic. They serve a quiet, protective function, acting as microscopic cushions against the forces of nature. When a raindrop falls from the height of the canopy, it carries kinetic energy that, if unchecked, could damage the fragile cellular structure of the cap or potentially wash away protective waxes and surface coatings. The presence of these small scales or fuzzy tufts disrupts the direct impact. They introduce air pockets and create turbulence around the water droplet, gently diffusing the force of the collision. Instead of a hard, concentrated strike, the energy is spread and slowed, allowing the water to settle more softly onto the surface before beginning its slow journey down the cap's slope toward the soil. This quiet interaction maintains the structural integrity of the mushroom during rainfall, preserving the delicate balance necessary for life. Furthermore, these textures can assist in preventing the sheet erosion of the cap's outer layer, which might otherwise expose the underlying tissues to desiccation or harmful pathogens. It is a detail of design that speaks to nature's thoroughness, where even the softest texture has a precise, engineering role to play in safeguarding the delicate process of life and reproduction against the ceaseless, gentle pressures of the weather cycle. 78. The mild, milky taste of some edible varieties is derived from their quiet uptake of specific minerals absorbed directly from the surrounding soil. The flavor profile of a fungus is a geological echo, a silent record of the ancient ground from which it sprang. The gentle, often subtle, milky or earthy taste associated with certain edible varieties is not arbitrary. It is a direct consequence of the quiet, selective absorption of specific minerals and trace elements drawn up from the surrounding soil matrix by the extensive hyphal network. These minerals, such as calcium, potassium, or specific salts, originate from the slow weathering of the parent rock beneath the forest floor, granite breaking down over millennia, limestone dissolving under the influence of acidic rain, or volcanic ash gently enriching the substrate. The fungus possesses highly efficient transport mechanisms, actively seeking and absorbing these micronutrients from the soil solution, integrating them into its cellular structure. As the water content evaporates during cooking or drying, these concentrated mineral salts become perceptible to the human palate, defining the mushroom's subtle character. Thus, a fungus growing on iron-rich soil might carry a slightly different, deeper note than one found in a heavily calcareous area. The delicate, milky quality signifies the presence of specific compounds that have traveled a long, slow journey from the deep earth, through the fungal network, and into the fruiting body. The experience of tasting such a mushroom is a momentary connection to the quiet geological history of the location, a flavor distilled slowly from the ancient, patient earth itself. 79. They demonstrate remarkable resilience, often quietly repairing damage to their mycelial network after physical disturbances or minor erosion. The mycelial network, the primary and perennial body of the fungus hidden within the soil, is a system built for quiet resilience. Though vast and often fragile in appearance, composed of thread-like hyphae, it possesses an extraordinary capacity for self-repair following disturbance. Should a minor erosion event occur, or if a passing animal or a tree root severs a section of the network, the integrity of the system is immediately threatened. However, the fungus does not succumb to this damage. Instead, a silent, internal triage begins. Cellular signals are rapidly transmitted to the area surrounding the injury, initiating a process of compartmentalization. The damaged hyphal cells are quickly sealed off, preventing the leakage of precious cytoplasmic fluid and nutrients, a quiet defense against internal collapse. Immediately following this seal, the surrounding hyphae begin directed growth, driven by internal chemical gradients. They grow rapidly toward the severed ends, weaving new cellular bridges and re-establishing the pathways for nutrient and water transport. This quiet biological self-repair ensures that the continuous flow of energy across the vast network is restored with minimal interruption. It is a continuous, subterranean effort to maintain homeostasis, a steady affirmation of the organism's deep, quiet commitment to persistence and stability, demonstrating that life continues to flow, even after tiny, localized traumas, through the rapid and efficient mending of its own intricate, living threads. 80. Some earth-star fungi gently peel back their outer layers upon maturity, creating a star-like pattern that slowly lifts the spore sac upward. The earth-star fungi offer one of the most elegant and slow unfolding ceremonies in the fungal kingdom. Initially, the organism rests tightly closed, often resembling a small, soft, rounded puffball hidden beneath the leaf litter. As maturity approaches and environmental conditions, particularly humidity, reach the optimal level, a slow process of transformation begins. The outer wall, known as the peridium, is composed of several layers which respond to the surrounding moisture content through a phenomenon known as hygroscopy. As the air dries gently, these layers begin to peel back, not in haste, but with a measured, deliberate slowness that takes hours or days to complete. The splitting occurs in a precise, radially symmetrical pattern, resulting in a shape reminiscent of a star lying flat upon the ground. This opening is not just decorative, it is functional. As the star points curl backward, the central structure, the small sac containing the precious spores, is quietly lifted and elevated above the damp, cluttered surface of the soil. This slight elevation is crucial, placing the spore sac where passing air currents can more effectively capture and distribute the fine, dust-like spores when the sac is gently compressed by a raindrop or a gentle touch. The final result is an architectural adjustment, a quiet, slow deployment of a natural mechanism designed to improve the chances of dispersal, ensuring that the next generation is carried lightly upon the breath of the wind, completing the slow, deliberate cycle of appearance and release. 81. The subtle, slightly rubbery elasticity of many stems allows them to gently sway with the soft wind without easily snapping or breaking. This gentle yielding is a marvel of quiet material science, engineered by nature to interact harmoniously with the movement of the air. The internal structure of the cells, largely composed of cellulose and other supportive fibers, provides a balance between necessary rigidity for vertical growth and the essential flexibility required to survive the minor disturbances of the forest microclimate. When a breath of wind arrives, a slow, continuous wave, the stem does not resist abruptly but instead curves gracefully along the vector of the force. This movement dissipates the energy, much like a patient reed bending beside a slow river current. The physics of this elasticity means that the force is distributed evenly throughout the structure, preventing any single point from bearing too much strain. As the gust passes, the stem slowly, almost imperceptibly, returns to its original vertical orientation, relying on the quiet memory stored within its cellular arrangement. This constant, slow ballet of swaying and rebounding reflects the quiet rhythm of the forest, where air molecules are always in motion, carrying scents and tiny particles across the floor. It is a slow, steady demonstration that strength in the natural world often resides not in unyielding stiffness, but in the capacity for gentle, consistent compromise, allowing the structure to endure countless cycles of atmospheric motion over its quiet lifespan. The quiet resilience inherent in this biological material ensures the continuation of the organism, patiently awaiting the optimal moment for spore release, while gently nodding to the passing breeze. 82. Fungi release warmth through their metabolic processes, contributing a small but continuous source of gentle heat to the cool, damp forest floor. This quiet warmth is a byproduct of the slow, steady breakdown of complex organic molecules, a process known as cellular respiration, which is essentially a very controlled, low-temperature combustion. Just as stars release energy across the vast emptiness of space, these microscopic biological engines convert stored chemical energy into usable vitality, and a gentle portion of that conversion manifests as thermal radiation. Though individually tiny, the countless unseen fungal networks operating beneath the surface contribute to the overall thermal signature of the decaying leaf litter. This continuous, patient thermal emission slightly elevates the temperature, immediately surrounding the mycelial threads, creating minute pockets of relative warmth in the otherwise pervasive coolness of the damp earth. This small temperature gradient aids in the quiet cycling of nutrients and fosters a slightly more active environment for other microscopic life forms that share the subterranean space. It is a gentle reminder of the first law of thermodynamics, observing energy's transformation in the quiet depths of the soil. The heat is never sudden or dramatic, but a constant, reliable presence, like the slow, steady pulse of geological time, assuring that even in the deepest, wettest shadows, biochemical life maintains its necessary, calming fervor. The whole process is a slow, steady respiration, breathing out just enough energy to maintain its intricate, unseen function, while subtly tempering the cold substrate around at 0.83. The white spores of many common varieties settle like a soft, quiet dusting of pale flour when released onto a sheet of dark paper below. This calm, predictable action of gravity upon microscopic biological structures allows us to capture the ephemeral beauty of the spore print, a patient map of the organism's reproductive effort. To create this gentle record, the mature cap is placed carefully over the surface of the paper, and then the quiet waiting begins. Over the course of many still hours, gravity and molecular vibration encourage the infinitesimal spores to detach from the gills or pores and drift slowly downward through the still, enclosed air. They settle in an exact radial pattern, tracing the perfect geometry of the structure from which they descended. When lifted away, the cap reveals a ghostly white impression against the darkness of the paper, a soft, fragile circle of pale powder. Each individual spore is too small to be seen without magnification, yet their countless accumulation creates a visible substance, resembling the finest, most quiet dusting of fresh snow upon the winter ground. The delicate whiteness contrasts beautifully with the deep, absorbing blackness of the background, emphasizing the silence and purity of the process. It is a slow, patient demonstration of simple physics, where billions of tiny packages of genetic potential surrender quietly to the pull of the earth, settling into a pattern that reminds us of the quiet, structured elegance inherent in all forms of biological dispersal. 0.84. Their preference for low light means they are often most abundant in the deep, shaded valleys and along the north-facing slopes of hills. This geographical distribution is not a matter of choice, but a quiet necessity, driven by the physics of moisture retention and solar radiation. Fungi thrive where the air remains consistently cool and heavily saturated, conditions that are often compromised by direct, intense sunlight. On the steep, quiet northern slopes, the angle of the sun remains low throughout the day, minimizing the direct energy input that would otherwise raise the surface temperature and accelerate evaporation. In contrast, the southern slopes receive the full, steady intensity of the midday sun, making them drier and less hospitable. Similarly, deep valley floors are often perpetually shrouded in the shadow cast by surrounding elevated terrain, allowing humidity to pool and persist long after the dew has evaporated elsewhere. The preference for darkness is fundamentally a preference for this sustained coolness and dampness, critical for the survival of the mycelial network that lies patiently beneath the soil. This quiet mapping of distribution across the landscape reflects the deep, unchanging cycles of the sun's annual orbit and the inevitable geometry of the Earth's surface. They reside where the light is gentlest and the water molecules linger longest, patiently fulfilling their role in the quiet, shadowed corners of the world, following the silent dictates of atmospheric physics and geography. 85. The sheer diversity of the fungal kingdom, encompassing millions of species, underscores the quiet complexity of their unseen world. This vast numerical expanse suggests a biological realm far richer and more intricate than the plants and animals we observe daily. Scientists estimate that for every known species, several others quietly await discovery, hidden within the soil, living within the tissues of plants, or inhabiting the deep sea environments. This quiet magnitude speaks to the tremendous power of biological evolution working over long stretches of geological time, steadily perfecting niches and diversifying molecular pathways. The vastness of this kingdom rivals the silent multitude of stars scattered across the night sky, most of which remain invisible to the naked eye, yet contribute fundamentally to the universe's structure. Each of these millions of species represents a unique, quiet solution to the challenges of nutrient acquisition and survival in every conceivable habitat. They orchestrate the steady decomposition of organic material, maintaining the Earth's delicate carbon cycle with tireless, silent efficiency. The scope of this diversity, from microscopic yeasts to vast subterranean networks covering miles, reminds us that the quiet, hidden processes of life often hold the greatest numerical weight, patiently shaping the ecological landscape beneath our feet with an overwhelming, steady variety that continues to unfold slowly, day after day, year after year. 86. Some birds' nest fungi quietly launch their spore packages, peridioles using the gentle force of falling raindrops as a miniature splash cup. This elegant mechanism is a perfect example of nature utilizing external, readily available energy for essential biological function. The small, cup-shaped fruiting body is oriented to catch the impact of a falling water droplet, a gentle yet forceful event delivered by the atmospheric cycle. When the rain descends, the velocity and mass of the water droplet strike the peridiole, the small, egg-like structure containing the spores, and the kinetic energy is transferred instantly. This quiet, instantaneous transfer generates enough momentum to gently eject the peridiole out of the cup. A fine, elastic thread often remains attached to the peridiole, acting like a quiet anchor that catches onto a nearby plant stem or blade of grass, ensuring the spore package is secured slightly above the damp forest floor. This elevated position facilitates a slow, steady dispersal as the peridiole slowly degrades, allowing the gentle air currents to carry the spores away. The entire process is a graceful interplay between the physics of fluid dynamics and the biological imperative to propagate, transforming the slow, inevitable cycle of rain into a precise, targeted launching system. It is a quiet, reliable dispersal technique, depending entirely upon the heavens to deliver the necessary energy for the next generation to be quietly carried to new ground. 87. The faint, sweet smell of yeast, a type of fungus, is a reminder of the quiet, essential role they play in many human food preparation processes. This gentle aroma is the molecular signature of fermentation, a steady, calm biochemical process where yeast cells slowly consume sugars and produce ethanol and carbon dioxide as byproducts. The sweetness in the scent comes from the residual sugars and the delicate esters created during this molecular transformation. In the making of bread, this quiet biological activity allows the dough to rise slowly, filling it with tiny pockets of gas that create the familiar light, airy texture. This process unfolds patiently, often requiring hours of stillness in a warm environment, embodying the virtue of slow, deliberate creation. Similarly, in the brewing of beverages, yeast acts as the quiet alchemist, transforming simple grain sugars into complex flavors and aromas, working ceaselessly in the cool, controlled darkness. The smell itself, subtle and comforting, is a chemical wave carried through the air, gently signaling the steady conversion of raw materials into nourishment. It is a deep, historical partnership, reflecting humanity's quiet reliance on this microscopic life form to enhance flavor, texture, and preservation. A steady, gentle reminder that even the smallest organisms wield profound, silent influence over our most fundamental, comforting rituals. 88. Certain fungi actively sequester heavy metals from the soil, acting as quiet, gentle cleansers of environmentally contaminated sites. This remarkable biological ability is a manifestation of the fungi's patient chemical aptitude, utilizing their vast network of mycelium to absorb and bind toxic ions. These heavy metals, such as lead or cadmium, are slowly drawn into the fungal structure as the organism grows and extends its hyphal threads through the soil matrix. The fungi naturally incorporate these metal atoms into their cell walls, or sequester them safely within internal vacuoles, effectively removing them from the surrounding environment. This slow, steady process of bioremediation occurs without drama or sound, a quiet, continuous purification unfolding beneath the surface. It is a gentle, nature-based solution to environmental damage, relying on the inherent molecular affinity of the fungal tissue for these compounds. The mycelium acts like a vast, unseen filter, diligently performing the necessary task of restoration over quiet months or years. This demonstrates the quiet resilience of biological systems, offering a slow, non-invasive method for returning contaminated land to a healthier state, patiently binding the pollutants until they are rendered inert or can be safely harvested along with the fungal biomass. It is an act of steady, chemical generosity, quietly working to harmonize the disrupted balance of the Earth. 89. The subtle change in the angle of the cap over the course of the day is a slow, quiet adjustment maximizing spore dispersal efficiency. This minute movement is not driven by muscles or complex nervous systems, but by the quiet, steady hydraulics of cellular turgor pressure. As the organism matures, internal water movement causes some cells to expand or contract slightly, resulting in a gentle, almost imperceptible tilt of the cap relative to the stem. This slow adjustment is often aimed at ensuring the gills or pores are perfectly perpendicular to the pull of gravity, guaranteeing that when the spores are released, they fall straight downward into the quiet air currents below. A slight deviation from vertical alignment could cause the spores to settle prematurely back onto the cap or stem, hindering dispersal. Therefore, the organism makes a continuous, quiet effort to optimize this angle, gently counteracting any subtle shift caused by slow growth or minor environmental disturbance. It is a precise, physiological calibration, driven by the quiet necessity of propagation, much like a plant stem slowly orienting toward the light. This slow, intentional movement ensures that the millions of microscopic spores achieve their perfect trajectory into the atmosphere, relying on gravity and the subsequent gentle lift of the breeze to carry them quietly away to potential new ground. 90. The slow expansion of a newly fruiting body can exert tremendous, quiet pressure, sometimes pushing aside small stones and displacing solid dirt. This hidden power is a testament to the cumulative force of cellular growth, a steady, hydraulic energy that operates without visible speed or noise. As the tightly packed cells of the nascent fungus slowly absorb water and expand, they generate internal turgor pressure that is multiplied across the entire growing surface. This continuous, low-speed application of force is immensely powerful, capable of overcoming the inertia and friction of compacted soil and small fragments of rock. It is a slow, irresistible strength, akin to the quiet, continuous push of tree roots splitting pavement over years, or the steady uplift of geological strata over eons. The displacement is not violent but deliberate, a gradual yielding of the earth to the persistent, gentle expansion of biological necessity. The quiet determination of this growth process means that the solid obstacles are simply moved aside, illustrating the principle that consistency and slow, steady application of force can achieve what rapid impact cannot. Observing a small mushroom cap patiently emerging through a layer of tightly packed gravel reveals this quiet, inherent strength. A slow, gentle assertion of life making space for itself against the silent resistance of the non-living world. 91. The silent journey of the Piptoporus botulinus fungus speaks to a deep, forgotten history, a connection spanning across many quiet millennia. This small, unassuming bracket fungus found itself resting softly among the few preserved possessions of Ötzi the Iceman, a man who took his final, long slumber high in the cold, still air of the Alps many thousands of years ago. It suggests a slow understanding of natural chemistry held by ancient hands, a knowledge passed down not through written scrolls, but through the gentle rhythm of seasonal gathering. Perhaps it served as a subtle, soothing medicinal resource, quietly settling the discomforts of a harsh, traveling life, offering a silent palliative in the thin mountain atmosphere. Or maybe its purpose was purely practical, acting as a reliable, slow-burning tinder, a gentle ember carried close to sustain the crucial warmth required to survive the steep, chilling slopes. The fungal structure itself embodies patience, existing in a persistent, woody state that resists the swift forces of decay, allowing it to become a quiet time capsule, linking the molecular memory of a prehistoric forest to our modern, fleeting gaze. This ancient material, resistant to the fierce alpine winds and the relentless crush of glacial ice, reminds us that biological cycles are vastly longer than human ones, continuing their slow, necessary work regardless of the passing of ages or the quiet tragedy of a lone traveler's final rest. It traveled with him not as treasure, but as a known, dependable tool drawn from the deep, encompassing wisdom of the natural world, a gentle companion against the overwhelming silence of the high peaks. The steady, internal chemistry of the fungus remained constant, a quiet reassurance across the silent, shifting epoch of human civilization and geological movement. 92. The fine, nearly invisible mantle of hair that often covers the outer surface of certain fungal caps is a marvel of delicate geometry, designed for quiet thermal stabilization. This soft, downy layer works ceaselessly to maintain a steady, gentle environment within the cap's protective architecture, insulating the crucial, developing reproductive structures. Like a careful blanket placed over sleeping seedlings, this coating minimizes the rapid loss of warmth during the chill of a forest night and gently shields the internal space from the sudden, drying heat of the afternoon sun filtering through the canopy. The tiny hairs capture and hold a thin layer of still air close to the surface, creating a subtle, personal microclimate that resists the more chaotic shifts of the surrounding atmosphere. This thermal inertia is vital because the delicate process of spore formation requires precise, stable biochemical conditions. Sudden temperature gradients can disrupt the meticulous cellular division necessary for successful reproduction. The cap stands quietly, a small, dome-like planet providing constant, unwavering conditions for the life sheltered beneath its gentle curve. It is an act of biological engineering, dedicated to stillness and continuity, ensuring that the critical moment of maturity is achieved without the stress of environmental variability. This focus on internal consistency mirrors the steady, slow rotation of celestial bodies, where slight deviations in temperature or orbital path can dramatically alter the conditions for life. The fungal cap simply breathes slowly, moderated by its hairy shield, waiting patiently for the moment of perfect balance before it gently releases its invisible payload into the cool, stable forest air. 93. The slow, quiet forces of the environment sometimes provide the subtle, unexpected cue for biological action, much like the barely perceptible energy carried by low-frequency vibrations. When a large animal moves silently through the underbrush, or when the quiet rush of water flows steadily through a nearby hidden stream, these events generate subsonic waves that travel through the damp soil and air. These vibrations, often too low for the human ear to register, can trigger a delayed, necessary release of spores from certain mature fungal structures. It is thought that this sensitivity evolved as a means of ensuring spores are launched only when atmospheric conditions are optimal, perhaps sensing the subtle pressure shifts or air currents created by the movement of mass nearby. The internal mechanisms of the fungus, waiting in a state of carefully held hydrostatic tension, respond to this molecular shift. The gentle rumble acts as a biological key, momentarily altering the internal balance required to keep the spores contained. The energy transmitted is slight, yet it is enough to overcome the adhesion forces holding the spores in place, initiating the subtle, explosive discharge. This reliance on environmental cues demonstrates the deep interconnectedness of the forest floor, where the passive movement of one life form provides a necessary condition for the reproductive success of another. The earth itself acts as a conductor of information, transmitting the presence of flowing water or passing life through quiet, rhythmic pulses, ensuring that the dispersal occurs during a moment of ecological relevance, a slow response to the planet's own steady, vibrational breathing point. 9.4. The deep, rich shades of crimson and mahogany found in the caps of certain fungi are not merely decorative, but function as clever biological adaptations rooted in the physics of light absorption. In the dense understory of an old-growth forest, only a fraction of the sun's initial spectrum reaches the forest floor, primarily the soft, scattered blue and green light that the dominant chlorophyll-laden leaves have rejected. To thrive in this constant, subtle twilight, fungi employ specialized pigments, often melanins or complex carotenoids, that efficiently capture the remaining minimal photons. These deep, dark reds are highly effective at absorbing light across a broad range of the visible spectrum, drawing in the scarce energy that filters down through the dense green filter above. It is a biological strategy of maximizing efficiency in an energy-poor environment. The fungus is not photosynthetic, but these pigments play a crucial role in protecting the sensitive internal tissues from the very small amounts of ultraviolet radiation that might penetrate, or perhaps in managing the temperature gradient through efficient absorption and conversion of light energy into subtle heat. The cap becomes a slow, quiet light collector, its deep color a testament to the persistent darkness it inhabits. It stands as a profound architectural statement of survival beneath the chlorophyll shadow, absorbing the muted blues and the lingering traces of yellow light that escape the upper canopy's hungry grasp. This deep color represents a patient acceptance of the minimal light, transforming sparse photons into stability, a quiet, necessary feature of life lived in the cool, constant shade of the perpetual woods. 95. The hidden, complex work performed by the mycelium beneath the soil serves as the quiet, crucial bridge in the vast, slow cycle of nutrient transfer, digesting the materials that others cannot approach. Mycelial networks possess an incredible enzymatic patience, specializing in the silent decomposition of complex carbohydrates like cellulose and lignin, the rigid architecture that gives dead wood its strength and permanence. Plants, having used these structures for growth, cannot reclaim their energy once they are solidified, leaving them locked away in woody debris. The mycelium acts as the persistent unlocking agent, secreting specialized, powerful enzymes that slowly and continuously break down these massive molecules into simpler, absorbable sugars and compounds. This is a process of deep chemistry carried out with utter stillness, ensuring that the vital carbon and nitrogen held within the fallen trees are released back into the living soil matrix. Without this constant, quiet digestion, the forest floor would become perpetually buried under undecomposable material, halting the nutrient exchange that sustains all green life above. The mycelium thus governs the speed of the forest, regulating the slow movement of energy from the dead back to the living, functioning as a subterranean engine of renewal. It forms a vast, unseen circulatory system, a delicate web of threads that silently transports refined nutrients across wide distances, feeding trees and smaller plants, weaving the entire ecosystem into a coherent, self-sustaining unit. This slow, steady work ensures that the flow of life remains unbroken, a perpetual guarantee of future growth and peaceful decay. 96. The sound of a mushroom cap achieving its natural separation from the stem is one of the most subtle, quiet events in the entire forest, usually escaping the notice of any passing creature, existing only in the microscopic acoustic void. It is the sound of cellular adhesion yielding, the final, gentle shear of tissue fibers that have held the structure together during its days of maturity. This slight, rhythmic detachment occurs often, silently repeating across the forest floor, marking the completion of the fruiting body's short, visible life cycle. The moment itself is governed by subtle forces, perhaps a slight shift in hydrostatic pressure, or the drying of the connecting membranes, resulting in a faint, dry friction that is instantly absorbed by the damp moss and soft surrounding soil. This unheard event is part of the continuous, secret drama of the undergrowth, where countless crucial transitions happen without applause or recognition. The forest operates on a scale of profound stillness, where the most important ecological actions are often those that produce the least amount of noise. The quiet fall of the cap, having fulfilled its duty of protection and spore dispersal, signifies its gentle return to the soil, where it will swiftly join the complex fungal digestion below. It is a meditation on hidden work and unseen transformation, reminding us that life's most persistent rhythms are often those that move beneath the threshold of our hurried senses, requiring absolute stillness to even begin to perceive the faint, essential sound of separation and slow surrender. 97. The sudden, often spectacular appearance of fruiting bodies after a gentle autumn rain is a perfect example of biological timing and environmental synchronicity, a response to a constellation of ideal conditions. The autumn period brings the critical elements together. The air cools, reducing evaporation and preserving moisture, while the forest floor becomes deeply saturated by the steady, quiet precipitation. This infusion of water is the essential trigger, allowing the subterranean mycelial network to quickly hydrate and build the necessary turgor pressure needed to push the fruiting structure swiftly above the soil. The cool, still air helps maintain the delicate cap structure and slows the decay, granting the fungus a longer window for spore maturity and dispersal. The rain washes the forest floor, reducing the density of competitive microorganisms and creating a brief window of perfect ecological opportunity. It is a moment of maximal energetic output, concentrated into a few days following the hydrological cue. The mycelium, having patiently stored energy throughout the dry summer months, expends that reserve in a quiet, rapid burst of vertical growth. The perfect saturation of the soil ensures smooth, unimpeded cellular expansion. This sudden, silent flourishing suggests a deep sensitivity to the seasonal rhythm, waiting for the precise convergence of moisture and temperature that signals the beginning of the quiet transition into the winter dormancy, ensuring the next generation is secured before the deep cold sets in. 98. The patience exhibited by some fungi, remaining in a perfect, contained dome-like state for many quiet days, is a profound biological waiting game driven by the necessity of flawless spore dispersal. The dome shape is an architectural masterpiece of protective containment, shielding the gills or pores where the spores mature from external threats like drying winds or sudden downpours. The structure is essentially holding its breath, waiting for the precise, ideal moment of absolute atmospheric stillness and appropriate humidity before committing to the final act of maturity and release. If the spores are ejected during a moment of high atmospheric turbulence or strong air currents, they are scattered chaotically and fail to land in receptive environments. Therefore, the fungus waits patiently for a cool, calm morning or a deep, windless night, conditions that allow the invisible spores to settle gently and predictably near suitable growing substrates. This biological patience is immense. The structure resists the natural inclination to complete its cycle prematurely, maintaining its integrity, while the internal biochemical processes slowly prepare the spores for flight. This state of patient latency reflects a profound commitment to reproductive success, prioritizing precision over haste. It demonstrates an innate wisdom about the physics of air and atmosphere, holding potential energy in abeyance until the chaotic environment briefly quiets itself, granting a small, necessary window of absolute peace for the crucial task of ensuring the slow continuity of life. 99. The smooth, gentle curves and subtle concavity, often found along the edges of many fungal caps, appear to offer a quiet, temporary welcome to the smallest inhabitants of the forest floor. This gentle topography provides a natural, unintended resting place, a momentary perch for small creatures navigating the complex architecture of the undergrowth. A dew-laden beetle may pause to absorb the morning sun on the quiet curve, or a tiny arthropod might seek shelter from a passing flurry of soft rain, utilizing the cap's natural smoothness as a temporary, stable platform. The geometry is one of subtle hospitality, offering a stable surface unlike the rough bark or jagged edges found elsewhere in the debris. These resting places facilitate the slow, necessary interactions within the microecosystem. Insects landing softly upon the cap may unwittingly carry tiny spores to new locations, participating in the quiet, necessary dispersal that ensures the fungus continues its silent spread. The cap, in its ephemeral existence, serves not only its primary reproductive role, but also functions as a gentle, smooth node within the ecological network, supporting the transient lives of many tiny beings. It is a piece of quiet infrastructure provided by nature, a momentary stage for the small dramas of the insect world, reflecting the deep interconnectedness, where one organism's structure provides an unforeseen comfort or necessary stability for another, fostering a continuous, slow flow of life across its smooth, curved expanse. 100. The quiet, profound world of mushrooms and their vast, hidden mycelial networks continues its slow, essential labor, forming the very foundation of the forest's enduring, sleeping health and ecological flow. This work, conducted almost entirely beneath the threshold of visible awareness, is what sustains the deep, rhythmic breathing of the entire wooded ecosystem. They are the silent regulators of carbon, ensuring that the necessary elements are continuously recycled and that the massive volumes of stored energy are gently returned to the living cycle rather than remaining locked in eternal stillness. The mycelium acts as the subterranean nerve center, facilitating communication and nutrient sharing between trees, softening the competition and promoting systemic well-being. This hidden life guarantees the slow, necessary flow of time and matter, maintaining the soil structure, stabilizing water retention, and quietly governing the pace of decay and renewal. The presence of the fungus assures that the forest operates not as a collection of isolated organisms, but as a vast, coherent system in perpetual, gentle balance. Their quiet perseverance against the forces of stasis and their relentless chemical work ensure that the cycles of growth and rest proceed smoothly, without interruption. This unseen labor provides the deep, continuous assurance that even when the forest sleeps under a blanket of winter snow or rests beneath the heat of a summer drought, its fundamental health is being maintained, preparing for the slow, inevitable resurgence of life in the next gentle cycle of the seasons.